6 years ago. We've been kind of working on the platform for a long time. And so I work for a Microsoft partner. We help customers get onto the platform, training and kind of proof of concepts and kind of just make sure people can get on well and land and are successful.
Thank you, Neil. So I feel very privileged to have him here. He's worked with a lot of customers. He has a lot of really deep answers to many questions. We also have Christine and Tobiah in the audience who are
There's a lot more flexibility when people start thinking of a SQL store and the tricks like that. You don't have to, you don't think denormalize, you might actually under-normalize data, actually so rapidly data, different data. It makes your life easier from a query perspective. Yep. Web job that just goes out and checks what VMs are running and stuff like that. And it doesn't cost pretty much as much. I think you can even I think you can actually schedule. I think you can actually schedule the web job. You run on a schedule.
It's right there.
Web jobs are really next to the day, right?
Actually provided the lattice, the glue, the fabric, which allowed people to work with that. Administrators to administer those things, as the word says. Developers to manipulate.
Okay, to a site, and essentially there's an authorization endpoint and a token endpoint. So this authorization endpoint is where I log in. It provides the user interface. And then once I get logged in, I deal with, you can along the way add things to the token, look at the token, standardize the token. And what's the format of the token, by the way? It starts with a J, ends in an N, and it's 4 letters. JSON format. So it's a web-based, traditional JavaScript can let you look inside the token. So this is OAuth 2. And then there's this whole concept of OpenID, which is kind of an industry standard.
And they'll spin up 3 new ones, or they'll get rid of 6. And because it has the package to do the deployment, it can just keep doing this forever. There's no more work from you. On the infrastructure service side, it doesn't have that package. It doesn't know how you want to configure the machines. You're responsible for the deployments yourself. It's like getting a new PC. You want to set it up the way you want it. Microsoft doesn't know how you want to set it up. And same with infrastructure service. Microsoft does not know how you want things set up. It knows you want a Windows server or a CentOS or a Ubuntu, but it doesn't know how you want the machines configured. So you have to tell Microsoft how you want to configure it. So the way auto-scaling works there is you pre-configure the machines. And say you might configure 10 machines and then shut down 8 of them, and then turn on auto-scaling and you can scale from 1 up to 10 at that point. And then when it auto-scales, it just bring up one of the existing machines that you shut down and spin it up for you, and then shut it down. So it's more complicated and you have to pre-create the machines. But you don't pay for them when they're shut down, it's free, they're free. I mean, you pay a little bit for the storage, but it's fairly trivial. So it is a different model for auto-scaling IaaS, but it's the same in other clouds have the same situation. I mean, Microsoft doesn't know how you want that VM to look like configured. There's also websites which are very lightweight web hosting that Bruno alluded to. There's ASP.NET, there's Java, there's Node.js, etc. That one's got a very lightweight auto-scaling as well. That one can auto-scale because Microsoft knows how you want it, what you want on the website. So that's trivial to turn auto-scaling on. It's kind of like the PaaS service. They know what you want, and they just keep deploying it as far as you want. There's a limit to auto-scaling websites. I think we've got like 30 cores, 40 cores. Does that answer the question of auto-scaling? So there's 2 different models, one for IaaS and one for PaaS. And it's all to do with what's known and how you want the machines configured.
All right, excellent. Maybe we can kick off by just showing you the portal. Did you all realize the portal has been modified? Am I looking at the new one or the old one here? Anyone know? Here's the new one. Dramatically different. Why don't we teach you the new one today? Well, number 1, it's not fully baked. And number 2, all the labs that you're going to learn are based on the old portal. Does that change your knowledge later? No, it's just a different skin on the same technology underneath. So this is the new portal here, more modern, as they say. And this is the traditional portal. Some people like creatures of habit. They prefer the old one. Everything's kind of here on the left menu. I thought Neil and I would walk down this list here I think if you could walk away today just describing what each of these things do here on this list, you understand the entirety of the platform. Today, we're going to be focusing a lot on the notion of a virtual machine, the lab specifically. So the way to think about it, there's two main worlds. There's infrastructure as a service, where you manually provision a machine, remote into it, and configure it. This is old school. Amazon did this out of the gate from day one. Microsoft got serious about this about a year and a half ago now. We've been trying to get everyone to go here, cloud services, which is platform as a service. What's the main difference? We abstract away the virtual machine entirely. You're in Visual Studio, and you just say publish. So in other words, if I have an app written for a platform as a service, you will see that I'm just going to right mouse click in Visual Studio here. This is one of the 3 labs you'll do today. Well, you won't be able to do all the labs. There's just not enough time. These labs took me all day for just one. But they're pretty ambitious, you know, like this one's a full-blown app. So if I go here and I say publish, that's it. I'm publishing to as many machines as I want. In fact, if I click publish, it's going to put this whole app up into the portal, and I'm done. I never said give me a new VM. I never remoted into the VM. I never installed software on that VM myself. I just said publish. That's platform as a service. Some of you might say, well, how do you know how many you're going to get of each? Well, notice the configuration here of a web role and a worker role. The web role is the web front end. And I can go here and say, oh, it's going to be busy. Give me 10. And I want really big machines, A7s. So that means it's going to have a 56 gigabyte 8-way machine, 10 of them. It's going to be 10 Ferraris if I want. Or I could just say, give me 2, which is typically what I want to do if I want the service level agreement. Meaning that if I want to be guaranteed 95.95% uptime, I'm going to need to say at least 2. Same thing for my background process here, worker role. Worker role also has this concept of how many instances, how big of a machine. So if I put 2 here, and I go over here to my web role and put 2, guess what? That's 4 machines, 4 virtual machines up in the data center. That's platform as a service in a nutshell. I am not saying go create me a VM. I just say publish with those settings and I'm done. The gentleman Adam asked me, well, how do I change that number from, say, 2 to 5? Well, I could go here and put that 5 and republish. I mean, after all, that's just making changes here in my configuration files. Or I can go up to use PowerShell to automate it. I could create my own app and leverage the management API to do it programmatically, either in any language because it's REST enabled, but I could also use C# SDK to do the same thing. So if we look over here in the configuration file, you'll see the instance count. So that GUI I showed you is simply changing that number there. So when I publish, this is the file that the Cloud Fabric controller looks at and says, oh, Bruno wants 2 of these. That's how it knows how many I want. So how do I want to summarize this? Here in virtual machines, look what happens. If I say new, quick create from gallery, look at all the different types of virtual machines. Even, oh my goodness, is this for real? Microsoft's doing Linux? Indeed we are. So you can even say, give me a Linux VM. So after I do this, what do I have to do next? Remote into it, right? I have a bunch here. Let me start the ones I have. Let's see, I'm going to use this one for today's lab. This is part of your lab. I've already done it. This is my web server. That's my web server. And here's my database server right here. I'll start that one as well. I had a second web server. So I had 2 web servers and 1 database server. I had 3 virtual machines. I deleted the 1 web server to see if it would still run. And it does. It's just not going to load balance between my 2 webs. It's just going to go to the 1 now. That's the whole point, right? So this is a VM. And notice over here, the connect button here in the lower left. That's how I remote in after I create it. And guess what? Developers are adopting the IaaS much more than PaaS because I can migrate, right? Let's say you have a corporate app that's running on Windows today. I just make a VM and then just start installing all my stuff. Remote in and start installing my stuff. Whereas platform as a service, you don't remote in. You're in Visual Studio. You worry about your app and your data. So I would say, to kick things off today, that's one key concept you should all know. Infrastructure as a service versus platform as a service. Two core questions to ask yourself. Why would I choose platform as a service? What scenarios make sense for that? Greenfield projects, stuff that doesn't exist. You're just saying file new project, you're starting from scratch. You want the path of least resistance. It's probably going to be platform as a service. Because I'm not managing VMs. I'm not on the headache of scaling. It's more, now we're starting to see the blurring of lines. Puppet and Chef, to me, represent infrastructure as a service becoming like platform as a service, in that you have automation tools that are abstracting the headache of the VM. That's what it really boils down to. Are you abstracting the headache of the VM itself? That's the goal as a developer. You don't want to be logging in the individual machines and configuring them. You just want to be in Visual Studio and say, deploy it. Isn't that what Ruby on Rails kind of does as well? Right? Ruby does that. But, infrastructure is great for migration because I can mirror, I can even set up VPN. So let's go through some of these. How about Azure Websites over here? This is pretty remarkable. I can go over here to Visual Studio. I have a little web app. I can say publish. I can say publish it to Azure Websites. And I can say go get the existing ones I may have created. So this list here, by the way, where's that list coming from? That's from the portal. I've already gone to the portal and said, give me a new Azure website. But Bruno, I don't want to go to the portal. I want to do everything from Visual Studio. Well, I could do that too. I could just go over here and click on new. I'll say, okay, make this website called Bruno Neal. I don't think that one exists. It does not. Let's put this in the West US. I don't need a database right now. Let's worry about that later. Go and create. So I bet you there's going to be an Azure website, .net, called Bruno Neal when I'm done. I can prove that if I go back to the portal. I've already done this for my personal WordPress project. If we go back to the portal, notice here I have brunoturkley.azure websites. So this is my personal brunoturkley.com site that's running as Azure Websites. And it's based on the WordPress template, which is wonderful. It is wonderful to have the WordPress template.
One thing that Bruno did that he chose, I think, REST US for the data center. So Microsoft's got like 10 Windows Azure data centers now. It's got 4 in the United States, US West and US East. US West in California, East is in Virginia. Then it's got 2 older ones in Chicago and San Antonio. It's US North Central and South Central. It's got 2 in Europe, 1 in Dublin and one in Amsterdam. It's got 2 in Japan, came on stream this month or last month. It's got 2 in Asia, East Asia, in Hong Kong, and Southeast Asia, and Singapore. It's got 2 in China, in mainland China. It's the first public cloud provider with a GA data center in mainland China, in Beijing and Shanghai. And it's got 2 announced in Australia coming on stream this year, and 1 currently in preview in Brazil. And so the data centers are actually paired in geographic regions. So like storage, things you put in Windows Azure storage is you can configure geo-replication. So from US West to East can be configured. The idea there being if US West gets destroyed, you won't lose your data being US East. So there is this capability of geo-distributed replication. Inside a geographic area, except for the Brazil one, it's geo-replicated to US South Central. So you don't need to use that facility, but it's there if you're kind of concerned. It's more about Microsoft data center disaster recovery, but that capability is available for storage.
Yeah, that also gives me a chance to talk about this little piece of traffic manager. So Neil said, maybe have a global app that spans the planet and have users everywhere. But how do I know which data center my users are going to? Like if the ones in Australia, maybe I ought to go to the data center in Singapore, not the US for latency reasons. How do I control that? Traffic manager, that what I've highlighted right now. Traffic manager lets you automatically route the user to the closest data center based on ping, the fastest response time. So that's a way for us to solve the problem of so many different data centers. Where are the users being routed to? Traffic manager. So that's, check that off your list of what traffic manager is. Also, if one of the data centers goes down, it'll route them to the next data center. So let's go back to that example.
Question, yeah.
So currently, we're trying to migrate our company from AWS to Azure. One of the problems with AWS is the complexity of load balancing. The way their load balancing is set up, it balances your basically one geographical location. And you have to set up kind of a redundancy through the DNS server. With this sort of balancing, will it balance it across geographical locations as well?
Yeah, so traffic manager is a global traffic manager, kind of like Route 53, I guess. And so they made it very easy. It's very easy to configure. So what traffic manager does is it gives you three capabilities. One is if you've got services running in the different data centers or whatever many you've got, you can configure a single DNS entry point and it will route to geographic, the lowest latency. It's not up to the minute, it's like once a week or whatever they do a traffic map and work out what it is. The second configuration is active passive failover. So you could have a primary data center failover to the other ones. The third is a round robin kind of thing, which you may want in a single data center. So they're the three capabilities that Traffic Manager offers. So it brings you to a single cloud service. Inside that cloud service, you get a separate level of load balancing. So if you declare a public endpoint, say a 480 on a cloud service or a virtual machine service, and you've got 10 VMs behind that endpoint, you get the choice of either round robin load balancing or port forwarding. Obviously for websites, you would want round robin load balancing. It's not strictly round robin load balancing, but it's essentially close enough to make it worth saying that. Or port forwarding, like RDP, you want to port forward. You want to be able to get to individual machines with RDP, or with websites, you shouldn't care which VM you get. So you can get the global traffic management with Traffic Manager. You get the local load balancing on a single endpoint in the cloud service or virtual machine that does inside the data center. And you can obviously go further than that yourself. You can start managing like ARR and kind of do internal routing yourself. But the ones provided by the platform are Traffic Manager and endpoint load balancing or portfolio.
All of that managed and set up within Visual Studio?
A lot of that is, they're adding a lot of that tooling to Visual Studio. Personally, I tend not to look at that inside Visual Studio. I tend to look at the portal for that kind of stuff. The Traffic Manager, I think, has to be done in the portal, the old portal. And it's very easy. They made it very simple to configure. They didn't want some, you didn't need to be an IT expert to configure Traffic Manager. It's almost like, here's my three services, here's the URL you go to, here's maybe a ping endpoint to make sure it's alive and kicking. And here's my DNS name I want to use for the service. So we've made it very simple to use. You don't need to be an IT expert to use it from the portal. I think you can, there's some tooling like PowerShell tooling and API scripts.
But I'm showing it right now.
I'm not sure if it can all be done in Visual Studio.
Good questions.
I think the load balancing in a service can be configured in Visual Studio. You get a little bit more flexibility in the portal. So you should be familiar with the portal. You know, a lot of large things you probably also want to get into scripting and make it repeatable and stuff like that. Portal's nice to get going. If you're trying to large deployment consistently and repeatedly, you should probably start looking at some of the tooling options as well.
So we're just about ready to deploy this guy to Azure website. So when I'm done here, what I expect to see is
where did the password come from?
it's grabbing it from my Azure portal account. So I logged into the portal.
When he created his first website, he had to provide a password, and it's a password for the portal, just for websites. So it'll use the same password for all subsequent websites.
So I bet you if I go to the portal now, I'm going to see Bruno Neal as one of the sites. Let's go up here to websites, refresh. There it is. So the website now is running. And I'm navigating to it right now, in fact. So that was pretty seamless. So it kind of begs the question, there it is. And can you map your own custom domains?
You should be able to.
Yes.
And you can also do, you can do auto-scaling. It's a slider to do auto-scaling. You want to do it in the GUI, as opposed to just turning it on and
So here I show you how you would configure your custom site. So you have to go into shared mode on your Azure websites. You go to your dashboard, you say manage domains, and the key thing to have here is this IP address for your Azure website, because you need to go to your domain registrar and use this IP address there. I happen to have Network Solutions. So here's Network Solutions. I say manage my account. I go in here and I say edit DNS. And I go and edit my A record. And there's that IP address I just spoke to you about that I got from the Azure Websites portal. So I go ahead and do my A record here, but I'm not done. I now got to edit my C record. And this is kind of goofy. This was way too hard for me to do. I took hours to do what should have taken 1 minute because I didn't know what to type in where. So I did that here. You end up typing awverified.dub. So GoDaddy will have a similar one, and other registrars will have a different interface because I'm looking at Network Solutions here. But pretty much the same principle. A record and CNAME is what you'll map. So if you look at my Azure websites, if I go to, say, Bruno Turkley, Azure websites, I can just as easily here type in, BrunoTurkley.com. It's the same site. I've mapped the domain name. And this is WordPress, right? So I can go over here and say WP admin, and now I can administer my website. Like WordPress, right? You familiar with WordPress? It's a content management system. So I can go, here's my dashboard here for my website. I can change the photos, I can do whatever I want. Well, not everything, but I can do a lot of things without cracking open HTML or PHP in which it is written. How did I get a WordPress site? Well, it's at the portal. If I go back to the portal and say Azure Websites and say New, and I say from Gallery, look at all the different type of apps you can get in Azure Websites. And remember, we talked about this morning, Node.js, Java, Python, a number of other hosting frameworks can be used here. And I went all the way to WordPress, of course. You get it for free, so why you wouldn't sign up for this yourself? Later today, I'll give you, any of you members of BizSpark? So any of you not have access to the platform today? All the software for free. You can go sign up for BizSpark. If you have Oliver here in the front row is kind of an expert in that too. You can sign up and get everything for free, $200 a month with Azure for free. So you can, if you're paying, I was paying $99 to discountasp.net. I switched to this, I pay nothing. So anyhow, this is Azure Websites. The question becomes,
I went there last week and started sign up for this part. It said that the promo for the Azure is no longer available.
follow up with me, I'll circle back and I'll see what's going on with that.
You get a free trial if you get through MSDN now.
So yeah, now it's through MSDN, so if I sign up to BizSpark and I get MSDN as part of that, right?
Yeah.
So when you sign up for BizSpark, you get MSDN, I think a pro subscription or premium, and that has the benefits. If I go to MSDN right now on mine, you'll see this. If I go, I explore MSDN.com, Microsoft.com. Where's my type of micro.com. Let me get to a normal size font here. So here's my MSDN. If I go and say, go to my subscriptions, sign in. So any of you here that have MSDN, you can see that there is indeed an Azure aspect to this. So it's free. You get 10 free websites a month. But when you sign up for the, if you can do your own custom domain, then you go to a shared pricing model. So it's not, you don't get everything for free, but you get a basic site for free. So my question to all of you, we've looked at these three so far. And we also talked about traffic services. So where does websites fit in this picture compared to, say, cloud services? I would say that they're very much the same. You could even argue that Azure websites are kind of like software as a service, beyond even platform as a service. But I could also argue that it's platform as a service. So Neil, how would you answer that question? If I'd say, Neil, I'm confused. Should I do cloud services or should I do Azure websites?
So as Bruno pointed out, there's two different ways you can deploy websites. So there's actually three. You can deploy websites infrastructure service, but if you're doing IaaS website infrastructure service, you should really be asking, why don't I do it in PaaS? Because doing it in a PaaS cloud service is much easier. It's relatively easy. If you get a fairly normal IaaS deployment, it's pretty easy to add it to a cloud service and just deploy to cloud service. If you deploy to PaaS cloud service, you get the benefit of the scalability, the very, very low operational overhead of running a cloud service, running a website in a cloud service. So you can definitely deploy IaaS to virtual machines, but you're responsible for all of that deployment. You've got to deploy to multiple machines yourself. You lose the ease of autoscaling to a very high level on infrastructure service for deploying IaaS applications. So then you get the difference between the traditional PaaS cloud service and the Windows Azure website. So the difference there is websites were originally intended for very small, lightweight things, but now they become so popular they've extended. I think you can go up to like 30 or 40 cores in websites. But what you lose is the ability to put them into a VNet. So you can create a VNet for cloud services and IaaS and PaaS cloud service, in which you can put the front end of the VNet and have the back end in an infrastructure service. You can stand up SQL Server with no public internet access to it at all, but have your front end having public internet access. So the front end can be in a PaaS cloud service, the back end can be an IaaS service, and put them in a VNet and have them connect over a private network. You can also then have a VPN gateway, so you can have your on-premises connectivity directly into your back-end servers and manage them from on-prem without going through the public internet. With websites, you cannot do websites into a VNet, so you don't get that kind of capability. You can't get the VNet. You get limited ability to look at what's on the machine, but really Microsoft completely controls the machine. And you can get full VMs, but Microsoft still controls that machine, where the layout of it, etc. So you get limited management capability. So websites is nice if you want to scale up. You want to rapidly deploy websites and connect them. You can connect them to databases, but you're not going to get the VPN access to the database. You're not going to get VNet access to the database. So Microsoft will be like SQL database. You can hook up to SQL database, or through ClearDB, hook up to MySQL. And Microsoft does use it for services. So mobile services, which was meant to be an easy-to-use backend for people developing modern apps for Windows 8 and Windows Phone, or also iOS backends and Android backends. So and it's getting a lot of API-level features and notification features and authentication. Mobile services is actually a Node.js application written at the same technology as Windows website.
So we're looking at mobile services, which is next on our list, by the way. So before we go there, are we a little bit clear? I know you're not crystal clear on Azure websites, virtual machines, and cloud services.
So the difference is, if you want a sophisticated kind of interacting services with back-end SQL and front-end IaaS, you should probably look at cloud services. If you're really just looking at websites, a website would say a small need for a back-end, like a single back-end database. It's not going to scale too much, and websites are good.
And no need for VPNs.
No need for VPN. Yep.
So basically you just said, is there a good, clear path to scale up? I mean, you know how projects start.
Yeah.
Let's do something simple and then
Well,
it grows.
if you're doing like an IaaS website, it's going to be a pretty basic IaaS website. As I said, if you've got a fairly normal IaaS website that's not doing anything too unusual, it's very easy to put in a PaaS cloud service. You can more or less take your solution and then add the cloud service component, cloud service project into your solution and deploy it. It's a fairly easy task.
So here's
To
the
take a regular IaaS website.
So you can see this is Azure websites, and notice that there is a scale menu, and I can just bump this instance count. And then they also have all this free, shared, basic, and standard, which is more information about to what extent is your website on its own VM. So in other words, with free and shared, your website is an IaaS, and there might be other people on that IaaS with you. So if they've got a very Chinese app, you might get adversely affected. And then you might say, well, I don't want to share my VM. Well, think about basic and standard. And they also give you some of this instance count where I can scale it. How many different processes do I want to run for my app, for my web app?
Can you auto-scale it too?
Yeah.
What was it
Yeah.
called?
Can you also scale it? So you can also scale websites or the other services. And you can turn on auto scaling. It's one of the things you can configure in the portal.
So I don't think this one, so I'd have to go to basic and get more features. See, when I go to basic, then I can even start controlling the machine itself, the size of it.
There's one nice little feature. I'll steal Bruno's box here for a second. And there's a nice preview feature you can do. So you can do things like GitHub deployment. You can connect this up to source control. And this supports it supports several different source control options like GitHub or TFS, the Microsoft's version, or Dropbox. Because they're trying to make the website deployment as easy as possible.
Any GitHub folks here at their company? GitHub? Only one or two, really? Wow.
So I'm going to show you a sort of neat little thing. So here's the configuration page. And one of the, so you can do WebSockets now.
Everyone know what WebSockets are? They allow your browser to run asynchronous kind of socket-based connections right directly from within a browser.
So the option I was going to just show you, this is a previous thing. It's kind of a neat little feature for demoing and playing around with. Edit in Visual Studio Online.
Right, because it's probably just not, it's on free now in maybe or something.
It should work. Oh, this feature has deployment connection. Anyway, if you turn on Visual Studio Online, if you do this configuration, what happens, you can then edit in Visual Studio. You can edit your code in the browser. So if you're doing sort of, you're just getting started and you're just doing a little simple project, you can actually literally edit the project in the browser, save it, and it's immediately deployed. You don't even need to have any Visual Studio involvement at all. Visual Studio Online gives you like IntelliSense and stuff. It's a pretty neat little tool for playing around with basic things. Obviously, you're not going to get the full continuous deployment thing with it, but it's kind of nice for if you've got some quick fix you need, you can actually do it.
Are you saying, Neil, that I can go to edit source code in a browser,
Yeah.
in a live site? Yes, that's what
You
you
actually
said.
could if you wanted to do. But if you're just get going and playing around with learning how to do this, say if you want to learn Node.js, or I was going to get my son to learn Node.js, you could do websites using Visual Studio Online and just deploy it directly out. It's actually a pretty neat tool. You get all the color coding and IntelliSense stuff you like in Visual Studio Online.
Is this working for you guys? Where instead of jumping into PowerPoint, we're trying to jump into the portal so that when we go to the PowerPoint, you have some context about what we're talking about. We find that if we just show you PowerPoint, you can't map it back to the portal and understand where you would go in the portal to get a feature. So mobile services, that's also in our talk. That is, what exactly is this going to be for? Well, you can tell up here by the menu a lot of the different things you can do. So if I say, give me a new mobile service right now, if I do a quick create, I'll say, Bruno O'Neill again. Whoa, look, it's asking me about a database. Do you mean to tell me that when I create a new mobile site, it's going to create the front-end web service and a database all in one fell swoop? Yes, I do. And they have in preview mode the ability to write .NET code on the back end. I'll talk about that in a second. So here's where you've got all your login information here. I don't know if I remember the password for this guy. I could just create a new server and a new database. So what this simply means is that if I have let's say a number of mobile apps, I can actually, it's not really part of today's class very much. We don't talk about this, but I think you should know what it can do. One of the things you can do with this is have an API that you write. So for your HTTP verbs, post, get, delete, you can map functionality to it. So I could say, whenever they do a put and pass parameters in HTTP, I can go do some code on the server and return an answer. So API means you, the developer, can create a JavaScript API. And that goes back to what Neil said about Azure Mobile Services. This entire backend is written in what language? Do you remember what he said? Node. So Microsoft wrote Azure Mobile Services in Node.js. So this API lets you define an API that would be used by a mobile device. So maybe this mobile device wants to go get the latest tweets from Twitter. Well, I can code up a custom API in JavaScript and code it here. Scheduler, maybe I wanted at night to go and run a job where I process images that might have been uploaded. So I like to do batch processing at night. Push notifications, this is an amazing, I'm just blogging about this right now. So the big headache with mobile devices today is if I have an iOS or Android or Windows phone, I have different push notification services. For example, for Android, I have to use the Google push notification. For iOS, I have to use the Apple. And for Microsoft, we have one. So this lets you kind of centralize push notifications across all devices. Identity, well, that goes back to, do I want to leverage Facebook, Twitter, Google, or Windows Active Directory to log into my mobile device? So this takes care of that other big headache mobile developers have, which is managing identity. Here's the database side of it. This is going to let you play with your database if you want. We have a scaling scenario here as well. The dashboard's kind of cool. Shows you kind of what's going on. You got configuring your auto scaling properties there, setting up source control, so on and so forth.
So the original idea with mobile services was a lot of the client-side developers in Windows 8 or Windows Phone or in iOS or Android, they didn't necessarily know much about setting up backends in the clouds that were reliable and robust, etc. So the idea was to make it just provide a very easy to use backend. So like the data section that's tied up to the database comes with just 4 operations, 4 CRUD operations that'll, if you use them properly, they'll just write to the database for you without using any database code whatsoever. You can then tweak that a little bit if you want to sort of do validation, etc., or add other stuff to it using JavaScript or .NET. But the idea was to make it as easy as possible for developers who may not know a lot about doing back-end services, and make it essentially front-end developers who don't know about developing robust back-end services, make that easy for them. And that's the whole purpose of mobile service. Get people joined who are doing client-side development and give them a good back-end. Yep?
Question, there was just a moment ago, there was 2 database choices, SQL database and SQL Server. Talk a little bit about what's the difference?
Oh, I can't remember the things. So Microsoft's got, you can run SQL Server on a virtual machine. I mean, just regularly, you can get a Windows Server virtual machine with SQL Server pre-installed. Or you can use a product called Azure SQL Database. So what Azure SQL Database is, it's a pretty much almost fully functional version of SQL Server that Microsoft deploys for you. And it uses it almost as a platform as a service offering. So if you install SQL Server, you say, give me a new database, put the file here, the log over there, another file over there, and another log over there. With SQL database, you don't get any of that low-level administrative access at all. You just say, create database with this name. And it'll give you a database, then you can do all the standard SQL, create tables, etc., schemas, and all that kind of stuff, do queries. So Microsoft completely managed the server itself. All of the data is stored in triplicate, and it does core and write. So if you write to the database, if you write to your database, it'll actually store the data in triplicate, and it'll, as soon as 2 of the 3 have responded, yes, we've written it, it'll say okay. So it gives you databases now. You can go up to 5 with the premium offering, which is more expensive. You can go up to 500 gigabyte databases. The basic offering is up to 150, and you more or less pay by the gigabyte. And it's not a overly powerful. A single database is not that powerful. In your laptop players, the SQL Server is probably more powerful than the SQL database. It's very much designed in a scale-out model, that you have more than one. If you want to scale out, you have more than one. Each individual database is the same performance. So 51 gigabyte databases is way more performant than 150. And Microsoft has customers running thousands of these to scale out. So there's at least more than 1 million SQL databases being run from Microsoft now. I think the latest features in the preview version, you have point-in-time restore for the last 30 days. You can say, or the last month, you can say restore from this point in time. So that's available in the premium version. There's a whole bunch of capabilities in the premium version. It's a lot more expensive. But things like point-in-time restore, geo-replication, so you can have a primary and multiple readable secondaries across the world. It's automatically distributed by Microsoft. You don't need to do any sync or anything. It's a behind-the-scenes thinking. So that's what SQL database is. It's a very easy way to just spin up a database that you don't do any management of whatsoever.
That's why attractive. What do you lose? What functionality is not there?
In the standard version, you don't get
compared to standard.
So the traditional one, the preview still, I think it's still in preview. Premium sort, I think it's still in preview. In the standard version, you go up to 150 gigabyte databases. You don't get point-in-time restore, and you don't get guaranteed IOPS. In the premium, you can get guaranteed performance, but you don't get the standard. There is an SLA for the standard. There's not guaranteed performance. As I say, it's very much of a scale-out model. So you've got to take care of sharding, etc. yourself. But Microsoft has done stuff like, I think, Baltimore website 400 databases when they first launched. Although they said, the last time I spoke to guys said they would do it a lot less than that now. So it's a nice, easy way to just get a database up and running. For things like mobile services, if you're going to scale at the level of SQL database, of course, mobile services just pin you straight into SQL database. There's no management. You don't need to think about that at all. If you do want to back it up, the technique is to make a clone of the database and back up the clone. The reason to clone it is, if you take a backup of a production database, it has a significant impact on performance, whereas the clone is a lower hit performance-wise. So there's a lot of understanding how to manage these things. It's definitely not as easy as point-in-time restore.
So if you look at the portal, these are the 2 places you can do it: virtual machines and SQL database. So if you go to virtual machines and I say, give me a new virtual machine from the gallery, notice I can choose from all the different versions of SQL Server here. So there you get a full fidelity SQL Server, just as you've been used to on premise.
And you need a full fidelity database administrator.
Yes.
Because you've got to do all the backups, etc. As I say, with SQL database, I mean, you still have to do backups, but it's kind of, as I said, it's more about just make a clone and kind of, rather than have to manage all the files. With SQL Server and the VM, you have to manage everything yourself, all the users, etc., where the file location is. SQL database is meant to be a low management, easy to use, rapid to use service.
And it's in your lab here, SQL database. So if I say new, this is database as a service, is the way you can kind of think about it. I give it a name. Choose a server or create a new server. And now you've got a database.
So SQL database is a multi-tenanted service. Microsoft will likely spin up the servers themselves, put your database on them. So you can't do things like cross-database joins and cross-database access from inside SQL database itself. So it could be different servers.
Are there any limitations on, let's say, transact SQL capabilities or?
Yeah, so you can't.
No distributed transactions on.
Yeah, anything to do with this cross-database stuff doesn't work, and also .NET CLR stuff, you can't access the CLR because that'd be a security hole.
I would use it anyway.
And but you can do most of SQL supported. Most of SQL Server stuff is supported, but anything where it could impact other users is not supported. So there are throttling. You will get throttled if you try and push the performance too much. So you've got to be able to handle retries, which you should be handling any distributed system anyway. But it's particularly important in SQL database, which we get throttling. Because it's not meant to be a very high performance system. It's meant to be an easy to use managed system that you scale horizontally. So one difference I saw in the Bill talk last week, I went to the SQL database premium announcement. And so the person doing the talk said, the way to think of the standard SQL database, Azure SQL database, is you pay for storage. And it's about $10 for the first gigabyte, and it's charged for the storage. With SQL, Azure SQL Premium, you pay for compute, because you get guaranteed compute performance. So it's more expensive because compute is way more expensive than storage. And you had a question?
Yeah, I just want to know what, like for example, the mobile services, you can still get to a SQL Server database like behind a firewall?
So yeah, it would have to be behind a firewall. I mean, so you could spin up in a VM, spin up a real SQL server, but you'd have to be connecting. Then you'd have to open up your SQL server to have a public endpoint. It may be authenticated public endpoint, but still have a public endpoint. That's the difference. You can't put up websites and mobile services can't be put in a VNet. That's the negative of them. You can't be put in a VNet. The nice thing about using a VNet is you could have a PaaS front end that's on the public internet, and in the say the front end subnet, and then a back end subnet with none of the VMs in the public internet. So at least you can keep the VMs themselves off the internet if it's say SQL Server. You can get rid of RDP. You can turn off the endpoint like RDP. Excuse me. You don't need a 1433. So you can have a back end that's not on the public internet. And you can always put it back on if you quickly want to RDP and you can turn it on and turn it off. Or you can have a VNet. You can have a VPN go on-prem and VPN straight in. So that's the difference. So if you want to go from mobile services websites to a fully fledged SQL server, that SQL server has to have a public endpoint available that you come into. And you can lock it down, you can ACL it.
Okay, so it doesn't have to be an Azure SQL Server.
You could connect, well, from mobile service and from websites, you can connect to ClearDB, which is a MySQL as a service. That's
I've got a corporate database.
Yeah. Yeah. So if you had a corporate database somewhere with websites, you'd have to somehow open access to that corporate database and come in through a public endpoint across the public internet. You'd have to somehow clamp that down.
It's possible to do with services.
Yeah, because you have access to the code. I mean, on websites, you can write any code you like. So you can reach out to a third-party service. The issue is how do you secure that? So you'd have to authenticate against that and lock it down. But you can't domain join, for example. You can't domain join the user. Whereas if you're running in a cloud service with a PaaS front end and a back end, you can put AD in there and have everyone domain join.
So I'm looking at a replacement for IaaS running the DMZ
Uh-huh.
and making calls to the database.
Yeah. So in Windows Azure, the way you do that is you'd create a VNet, which may have a VPN onto on-prem if you want. But that VNet would have two services in it, a PaaS cloud service with IaaS running, say, a web role, and a back-end cloud service running IaaS cloud service running your SQL Server, and they can reach out over the VNet. The only negative currently is you cannot individually firewall. There's no separate firewall between the two. So if you can get onto the IaaS box, and if someone could hack onto the IaaS box, they could technically reach out to the other one and they can't firewall. You can turn Windows Server firewall on, but there's no separate like Barracuda or whatever firewall in that subnet. You can't firewall subnets, but you can use Windows Server firewall. But websites don't deal with that because you can't domain join them, you can't add them to that VNet. So you have to, everything from a website essentially goes over the public internet. Even going to SQL database is technically going to the public internet.
Another limitation is the size of the database. 150 gigs is the biggest you can go with SQL database.
For the basic, the premium you go to 500, but that $500, 500 gig premium is really expensive, to be honest. If you need it, you need it. It is,
Regarding storage, while we're on that topic, there's also a storage section here where you create your storage accounts. By the way, I wanted to mention real brief before I switch topics, I do have a full article about how you would migrate your databases back and forth between SQL database in the full on-premise SQL Server or SQL Server running in the VM, how you create the backpack files and all that. It's an MSDN. The other thing I want to talk about is storage, which we'll talk about right here, tables, blobs, and queues. That's later today. And also the other point I wanted to make is that you can support with Linux VMs any data model you want. MongoDB, CouchDB. Since we support Linux, there's really not a data model we can't run. And of course, we have Oracle up there as a VM. If you can believe that. If we go back to virtual machines here, and let's say you do have an Oracle VM, if you notice here from the gallery, we have fully supported Oracle over here. Anyone running Oracle here? Let me ask you the question differently. Anyone paying lots of money for a database?
I went to the Cassandra Summit last summer, and one of the Oracle boat was racing backwards and off Fort Mason. The Oracle boat was racing backwards and forwards. So there was a lot of jokes about it. And one of the guys said, so you can either use Cassandra or you can scale Oracle up until the money runs out.
It adds up.
So if you're using, if you have an application that has occasionally connected, let's say you have a local store and a SQL server store on the back end, perhaps in the cloud, what would you use for the local store, and what would you use for?
So where would the local store be? What do you mean by local store?
Well, stored on your local machine, so that the application can run if you're not connected to the cloud. And then later on, when you are connected to
SQL Express.
This, I'm not really a client. SQL Express is one option, I guess. The local
SQL Express.
files, the file system itself.
I think the question is
Well, you have
about
SQL
synchronized.
Express.
Is there synchronization capability like replication?
You have there is a Microsoft Sync
Yeah.
API, but I believe it's not that trivial to use. It's available, but people have tried to use it. So I think it's not that trivial, but it doesn't really support. It's not support per se in the cloud. You have to do both sides yourself.
Okay.
So it's really a client side issue. How do you do the client side?
Redgate has a product that helps with synchronizing SQL Server.
For just SQL Server, if you're in an enterprise environment that is like SQL Data Sync, it will do synchronization between them. It's still in preview, but that is available.
So it looks like people are starting to stretch their legs. Maybe we want to take a quick break. Come back in 10. Thank you very much.
I got a quick question, unless you want to go on.
Yeah, sure, go ahead.
You know, on the schedule, what are the,
I don't know, $10,000 worth of software. If you looked at the MSDN subscription lately, it's worth thinking about if you're currently paying for monthly cloud fees. There's a way to get 200. The other guidance I have here is once you go to your portal and you're not using your VMs, go over here and click the shutdown button here and get rid of it. All right, excellent.
Because ooh, that's loud. Been deafened.
There you go.
With VMs, if you shut down, if you go to the portal or use the APIs or whatever to shut down the VM, what it does is it gets rid of the CPU. You lose the server itself, but all of your disks are in storage. So you can just start it up the next day. So it's great for like dev, test, and demo environments. You can just run them during the day. You've got 20 VMs, shut them down at night, and you don't pay for them. During the day, you pay per minute from the first minute. Amazon, for example, charges for the first hour, and Google charges for 10 minutes. But Azure just charges from the first minute, it's a per minute billing. And let's say if you shut them down, you don't pay for them. So actually, I have a whole bundle of VMs. I've done different things, Active Directory, and they just shut down most of the time. And you pay a fairly normal amount for the storage. Then you just start them up, and they start up in just a few minutes. And so it's a really great for like dev tests and demo environments and IaaS. You can shut them down. And the PaaS cloud service, you can't shut them down. You can only delete. And the difference is that on the PaaS cloud services, you physically get you get a virtual machine with attached storage. When you deploy a cloud service, a PaaS cloud service, it'll come with 3 disks, a C drive, a D drive, and either an E or an F drive.
Where's that click?
A weird buzzing.
Coming soon.
We lost your mic.
There you go.
That's because we
I think it's totally away.
Got it.
So I think we just shut off all the speakers, unfortunately. How's that? Testing?
Can you hear me?
Go ahead and speak.
Mine was the back of the nice.
Jack, you can oh, I have a red battery too. All right. Well, I think there is batteries typically up here. There they are. There's one anyway.
I think I hear you pretty well.
Okay, I'm good.
Yeah.
Oh, this is not the correct. Jack in the front desk, if you want to check it there. One of the things I wanted to show is that with these databases, you can actually use all, even though these are cloud-based, I can go up to SQL Server Management Studio and connect up to them. Now, it might reject me because of my IP address, right? So I have to go back at the portal for this server, UX. So if I go back up to the portal and look up servers and I find UX here and configure it, I have to allow my current IP address of 167. So I'll click on it. I won't save, and I'll try to connect. And it's going to complain because it says that 167 is not on the, and I get this a lot when I go to parties, I'm not on the list. So what you can do is go and add it to the list and save. Thank you. Now, this IP address is allowed. Now I can go in here theoretically and connect. So I think what the advantage here is, and you do this with your labs, is you can go connect directly up to SQL database from your favorite tooling. Yes, there's a web-based portal at the Azure website. I can go modify it through a web, but who wants to do that? I want to be able to right mouse click. Now, if I want to now start exporting this to other environments, I choose this right here, extract data tier. So this is built into all versions of Visual Studio, even SQL database, which you recall is database. So I can extract this, store it as a blob, it's backed up as a blob, and I can now import it into any version of SQL Server. In that article I showed you, this is what we talked about. How do you extract your database tier? And they have a mistake here. It says SQL Azure. Remember the word SQL Azure? Has anyone run across this over the last few years? It's now called SQL Database. So don't get confused. Even our own tool, we're even confused about it still, because this is 2012. And I think it's also in 2014. At any rate, so I just wanted to kind of close the loop on the database a little bit. We're making great progress. We've gotten through these top 4 ones. Any questions so far? We're going to revisit these in PowerPoint, or depending on how much lab you want to do in labs themselves. So for example, one of the first labs is you're going to create your VMs. This lab right here. You're going to basically go and create 2 IISs and a SQL Server VM, so 3 total. And it shows you here, you're going to choose the virtual machine for SQL Server. You're going to basically configure that virtual machine. You're going to get one with 1 core. It's a very weak machine. And you're going to go over here and give it a service right here. So all 3 VMs will be part of the same cloud service. Why would you do that? Why would you care that 3 virtual machines are part of the same web service? So they can see each other. So I can open up the port on my 2 web servers, and my SQL Server is safe. The outside world can't get in. It's only accessible from the 2 web servers. So it's kind of creating a virtual network in a sense, kind of a little indirectly. So I'm walking you through this one lab. I want to give people a chance to play with some of this today. We can talk all day. And when we did this in Silicon Valley, people would rather have us just talk all day, much to our disappointment, right? Because it's nice to see you working. So we want to balance it out. If you choose to ignore us and you just want to start doing the labs, we won't be offended. So we want to make everyone happy if we can. So I thought I'd kind of bounce between PowerPoint, the portal, and the labs. kind of dot all the I's and cross all the T's. So here you are, you're at the portal now. You've got one SQL server. What's next? Your 2 web servers. So you're going to go here, create Windows Server 2008, give it a name. In this case, we're calling it IaaS VM1. You're going to have to create your own name, I believe. And here you are attaching to the same cloud service as the database. Why? Because the IaaS servers need to see the database server. And by making them the same cloud service, you achieve that goal. Okay, what else do we do? So now you can see we've got all 3 machines built. Are we done? Not by a long shot. What do we still have to do? We have to tell IaaS to go onto those 2 web servers. And for the SQL server, we've got to set up a user, set up some firewall rules, import the database, all that good stuff. So that's what the rest of the lab kind of walks you through here. Notice on SQL Server, everyone know the port, the key port here on SQL Server? 1433, so you're opening up port 1433 on SQL Server. That's what allows you to talk to the database with the tabular data stream, the TDS technology. So we're going to go in here and attach disks in the lab. So our SQL Server needs additional disks. You can add up to 16 1 terabyte disks. Is that still, did Bill change that? Do you know? So here's the first one, 50 gigabytes. We're attaching a disk. We're going to attach another disk. So now we're going to connect. You know how to connect to these? Let me show you that. I haven't showed you that yet. So if I go to my database, I'll go here to virtual machines. I'll click on my database. Oh, it never started, so I need to start it.
So these disks are not physically attached to the server, but in blob storage, storage section of Windows Azure. Unlike the PaaS, where they physically are. So in PaaS, they're saying there's 3 disks here on the server. That's like when you shut down a PaaS service, you still get the disk attached. You don't lose the server, you still keep paying for it. Unlike IaaS, where the disks are attached and shut the machine down totally safely. If the machine has to move, you don't lose your work because it's in storage. And then they just attach, like they have a driver that will attach to reach out to the network attached storage essentially.
Question, Oliver?
No.
So the lab I'm going through is the one I called. If you can do just one lab in Azure, just one, the one I'm showing you is the one you ought to do. Just because I think it's the most common use case, it's the most practical, and it makes the most sense for the new person because you're dealing with VMs. So I'm walking you through the one I gave you on disk. brunodevcamps.zip. Unzip that, you'll see one called Intro to VMs. That's the one I'm walking you through right now. I wanted to show you can remote into these machines. How would you do that here? Let's say I want to remote into this guy here, IaaS VM02. I'm going to click the Connect button, click Open, click Connect, and give my credentials to this one, Azure user, and my password. Now I'm remoting into that VM. Is this infrastructure as a service or platform as a service? Infrastructure, right? This is the manual, bogus way of having to log in and having to run scripts to configure it. I mean, you could probably configure this from PowerShell. The stuff that you're logging in remotely to do through remote login, you can do with PowerShell probably. And you probably would want to do that if you're doing this on a frequent basis or you're doing a huge web farm. You'd automate this.
Actually, recently PowerShell, you can do things in PowerShell you can't do from the portal. The PowerShell teams are more aggressive in the portal. The teams kind of work a little bit out of sync because they're not all the same time frame. So there's certain things you couldn't do in the portal you could do in PowerShell. And there's also there's a command line interface that will run on Mac and Linux. It's written in Node. All of that is open source from GitHub, so you can actually download it and look at yourself and tweak it yourself. Like what Microsoft did. So you can spin up all the machines, shut them down, configure them all from PowerShell. The CLI isn't quite as cool feature as PowerShell, but it's getting there.
Now, if you notice over here, I've got IaaS running, and part of your exercise will be to configure IIS on this raw VM, and then to create a folder called inetpub. I know you can barely see that here. Let me zoom in a little bit. The Zoom doesn't work with a remote session, but this is, I know what I can do. I'll copy this and go into my editor here. I can maybe increase the font. So what I'm showing you here is that you can go into this VM and configure IIS just like you would do it anywhere else on premises. So that's what this lab is having you do. So let's go back and check that out. Let me just make a big font out of this so you can see what's going on. So indeed, I have this folder, Cloud Shop. So that's a web application that you're going to install onto the web server, one of 2 web servers. So you're going to do everything twice because there's 2 web servers. And you can see here the web config. If I go and edit the web config, I bet you it has a connection string to the database. And sure it does. There it is. SQL VM01 right here. Let's see if I can increase this font again. So again, all manual stuff. Notice that's the name of my SQL Server database. Prove it, Bruno. I don't believe you. Okay, well there it is right there. SQL VM. Can you log into that one as well, Bruno? Yeah, of course. I'll just click here under running. Click connect, just like I did before. This is my database server now. So open up the RDP file, connect, type in Azure user, password. And now I'm remoting in to 2 VMs, my web server and my database server. And there's potentially a 3rd web server, but then I delete it. It'll run just like it does right now. In fact, let's see if I can run this guy. I'm going to go to my browser. Oh, let me close up. Here comes the SQL Server database machine. Let's go over here and say IIS Cloud Service Cloud Shop. Here's the web app running up inside a VM. It'll take a couple minutes for it to warm up, though. Cloud Shop. Come back to that. So again, we have 2 sessions now. My SQL Server is here as well. So I'm sure if I go to SQL Server Management Studio, you'll find that here, sure enough. SQL Server Management Studio, you want to run as administrator, of course. This is your lab 1. This is the one lab I think everyone should do. Still kind of booting up slowly. The name of this machine is SQL VM1. You can probably tell up here. Give it away here in the machine. It does not. Oh, there it is, SQL VM01, hostname. And of course, the web server is pointing to the database. How else would it get its data? So SQL Server Management Studio is taking its sweet time to boot up. I think it's a small VM. It's way under power to be running all this. Should have done medium. Here's another thing. Updates are available. Did you see that pop up? How is that different from Platform as a Service? You're responsible for updates here now in the VMs. Do they ever patch them at all, Neil, at any level, these VMs? Do they go in there?
Yeah, on the IaaS side, Microsoft will do a patch Tuesday update to set roughly of the underlying host operating system. So you'll see if you have an availability set, you won't actually get an email. But if you have single VMs, you'll actually get an email from Microsoft. I think I got one yesterday saying that on some schedule, like in a week out, we're going to reboot all the machines twice. So it goes through the sweeps through the data center and do post OS upgrades. We don't do guest OS upgrades on IaaS. It's completely up to you. If you don't ever patch them, they'll never get patched. On the PaaS side of things, Microsoft has a host OS upgrade, but you can also configure it to the guest OS upgrades. You can say, I'm happy, you guys go ahead and do it, and then we'll actually do guest OS upgrades as well, using upgrade domain technique I told you earlier. So you've got 100 VMs, so you 20 at a time, or however many you each upgrade domain. So they'll do host OS upgrades, guest OS upgrades, and then you can do application upgrades yourself. But you can turn the host OS ones up. It's up. You can configure it to do them automatically, or you can say, no, leave it at this operating system, and I'll do the guest OS upgrade myself on PaaS. But on IaaS, you're completely responsible for any guest OS upgrade.
So that's a big, decision to make, is automated upgrades. So this is the end game here of this lab. I'm now looking at one of my 2 load balanced web servers running, and I'm noticing data on this web server. Where's that data coming from? The database. Show me the data in the database, Bruno. Okay, well, let's go to the remote session for the database. Here it is. Here's databases. What you're going to create in this lab is you're going to go over here and do the AdventureWorks database. So you can theoretically go here and go get product information here, which I believe is where that data comes from. So you can obviously go here, remote in, and select your data. So that's what's going on in this lab. A few other noteworthy things to think about in this lab. Has this thing got us our data yet? Yep, here it comes. So the data you see on the website comes from the database, obviously. And notice what I did here. If I had 2 machines, I put the machine name. So when I did IIS1, I hard-coded IIS VM1. And when I did IIS Web 2, I put 2 in there. So if I could hit this over and over, you'll see that toggle between 1 and 2, because the load balancer is routing you to for different web servers automatically. You didn't set that up. So if I set up 10 IIS machines, it will automatically load balance across all 10. And you can prove it simply by hard coding the machine name into that specific website.
Do you have a question?
So let's just show you this lab. So if in the event you're interested, you're going to connect, of course, to the machine. You're going to shut off security on the web server, configure Internet Explorer to be able to go to visit websites. And here you are on SQL Server, well, actually on the Server Manager. Those disks that you attached, they're now going to be formatted. Why? Because one's for the database and one's for the database logs. Right? That's a best practice with SQL Server. Separate the logs from the database. Parallelize the I/O on there. So here you are creating an F drive and a G drive up on SQL Server. Done. And you can see now we have a formatted F and G drive. The next step is to create a data folder on the F drive and copy the AdventureWorks database into the data folder. And on the on the second attached drive, you're going to create a logs folder and a backups folder. Again, just a best practice. You could have just done this all off one drive if you wanted to. And so here we're going to now go and download the AdventureWorks database from Codeplex. Right? And notice over here what we're doing is we're copying it to that F drive we just created. Well, of course, we're migrating a database to the database server. That's what this step is showing you how to do. Now we're going to go into SQL Server Management Studio and play around with properties, like we want dual authentication mode in SQL Server, right? Because we need to create a user so that they can get data. And this is the first step in the security part of it all. And notice at the bottom here, we're mapping for the data in SQL Server. Tell SQL Server to go to F:\data, and for the log files and the backup files, go to the G drive that we attached and formatted. Again, we're configuring the database server here. We're going to restart SQL Server to make it happy, and then attach the database that we just downloaded to that machine. And you're going to set up the log file as well. The other thing the lab does is full text search, which, by the way, that gentleman that asked about limitations of SQL database, one of them is it can't do full text search. And in this app, you're doing that, right? Because I'm looking for cloud products. I can go up here and look up the word wash and get it midway through the list, right? I found wash using the full index search. So that's why you're doing this step, setting up full text search. You're setting up full text. I'm not going to walk you through all those details. This is kind of a key step. How do I set up the login now so my web server can log in, right? So I'm going to go create a user called Cloud Shop. We can see that if we go to the web server. Here's the web server. You can see we have a user over here called Cloud Shop. I want to be brave. I'll insert some words. And there's Cloud Shop right there. So we're adding a user here so that my web server can log in, of course. And that's what you're doing on the database server. You're configuring this user called Cloud Shop. And you're going to give it permission to the database we just added. You're going to make it owner. There's some better best practices here depending on how you like to configure. See, any DBAs here? All developers. Okay, so open up a port. Which port do we need to open up again? I forgot. 1433. That's what we're going to do, the SQL Server port. This allows the web server to get in. Now this port is not exposed to the rest of the world because we open up port 80 only on the web servers. We haven't configured the web servers yet, by the way, so stay tuned. What are we doing with these rules? Anyone know what this is all about? SQL Server rule? Firewall. We've got to let the firewall, let traffic flow through. We've got to tell the firewall what to do. Okay, now we're on the web servers. We can start configuring them. I already showed you that we added this Cloud Shop folder to the inet pub www root folder where they live. So now let's go open up, what port do you think for the web server? 80. So let's open up port 80, and you go to the endpoints menu at the portal. Makes sense. Go add an endpoint, and it's port 80, of course. You open up the ports on your web servers. Do it for the second one now, right? Because there's 2 web servers. You're doing everything twice in this lab for the website. Okay, so we did that. And now we're getting close. They have us connect up here. Again, you're playing with the IaaS. So here's where you set up IaaS. Application server. You're going to set up IaaS here on the web servers. Could you have shell scripted this? Yes. Okay, we're almost done with this one. Go in here through the wizard to set up IaaS. Here's kind of a little known gotcha that Brett and I noticed when we did the labs. You need to tell IaaS here. Let me make that command a little bit bigger. Has anyone played with this command ever? You're telling it to use .NET 4.0 for their application pool. You're just telling IaaS to use a more recent version of the .NET framework. 4.0.303. Okay, so this zip file is what? The assets folder, which is on your drive. This is the web app. This is where we go and paste it onto our machine and then unroll it into the web server folder. This is our web app. What do we need to do after we copy that guy in, do you think? What do we need to modify in the web config file? The name of your SQL server, right? You're going to have a different SQL server name. The connection string, exactly. So go down a little bit before you convert to an application. There's another step in IaaS to say it's a web app, blah, blah, blah. Then you go play with connection strings. And you can see here is where we tell it, hey, go to my database server. Here's a little gotcha. Notice there's no .cloudapp.net. It's just the name of the server. It didn't work when I did it the other way. Just the name of the database server. Where would I, if I told you to go validate SQL VM1, how would you go about doing that? Where would you go?
An ODBC connection.
It is an ODBC connection.
Usually you go to the admin tools, you go to the ODBC connection.
You can run it through a wizard. Yep. You can also go directly to the portal and say, hey, Bruno does have a machine called that. There it is, right? After all, aren't we connecting to this machine right here?
So that's a server name, right?
Right.
How do you specify I'll just tell, also it's not a local SQL server. That's-
Correct, it's a separate machine. So this machine here is talking to that machine there. And so the connection string in IaaS VM02 points to SQL VM01 in the web config file. And so, if all is good, you will see this show up. Brett kind of cheated though. If you look at the way he ran it, he's got it as localhost. Well, that means if you're running on the box itself, which we're not. In other words, yeah, I could go to localhost if I'm remoted in to IaaS VM1. But the outside world, you're going to want to go and do it like, so he did both. So it works. And notice he did the same thing I did. He hard-coded the machine name. And I bet you later he showed you that it's also VM2. Who decided whether you'd see VM1 or VM2? Well, the load balancer took care of that. It's a nice feature.
How much money did you just spend?
Well, for this lab, I would say a few pennies, because if you could do it in a couple hours. How much is the cost per hour of a VM?
It's like 9 cents an hour, something like that.
So it depends how fast.
And
With your MSDN subscription, it's like 6 cents.
You get $200 a month free.
6 cents an hour.
Oh, okay, so it's even cheaper.
Yeah. And you don't pay extra for the SQL server, you only pay for the virtual machine. So
Right.
for MSDN subscription.
So data costs are your most, so if you look at the main costs, which would be compute, storage, and bandwidth, let me ask you, which is the most expensive? Depends on the app, of course, but if you have a decent amount of data traveling, it's the bandwidth leaving the data center. So we'll take your data for free as an upload. As soon as it leaves the data center, that's when you get charged. And that's historically where the main costs are. And in Europe, it's even higher because they have some kind of special situation in Europe.
So the transfer between the application and the database is not that anywhere?
Well, as long as you stay inside the data center, there's no charges for bandwidth. So there are actually operation charges. You pay for storage operations, it's fairly minimal. And if you've got two services in the same data center, you won't be billed if you actually kind of normally leave the data center back in from one, go out from one and come in the other. If they're in the same data center, there's no charges. With bandwidth, Microsoft only charges for outbound. They don't charge for inbound traffic. Realistically, almost all the traffic is outbound. So if you've got an application that's got a huge inbound, then you get all the traffic for free.
So we're at this stage now where I think we can talk about more of what's on the portal and more content, or we can let you run loose and try that lab a little bit. Maybe I'm inclined to talk storage for just a little bit. Yeah, I agree. Let's talk about storage. And I think we have a whole storage.
Because they're using storage stuff.
So what we can do maybe is rifle through some of the PowerPoints to make sure we cover some uncovered territory that we may have missed. So I think I added this slide to my deck last night, which means that I can deploy these virtual machines with 3 ways. We just showed you the management portal way to do it, but you can script it. What does the REST API mean? Well, I could write a Java program that conforms to the REST protocol, and I could do it all from Java or whatever. REST is the web, right? The REST is HTTP, basically.
There's also a client library with a .NET client library was released to GA last week. Kind of, so anything you do with the REST API, you can also do from a managed library. It's a long ask. A lot of people didn't want to write to REST APIs if they're C# developers they didn't want to do it. So finally, there is a managed library now to do all of this stuff.
I have a blog post that shows you how to do it with the REST API, and I'm in Fiddler, I'm mucking around with the HTTP header. It's a real headache to deal with REST.
You don't need to do that anymore.
Okay, so did you know that you could have, no one asked this, but you could have your on-premise VHD and upload it to the cloud and hydrate it up in the cloud. And you can download the VHD down to your on-premises. So those VHDs you're creating are portable. And they're triply replicated, by the way, because all of storage is stored 3 times. All your blobs, which are files, are replicated 3 times. And then they have something called geo-replication, which means what? Within the same kind of continent or region, you can replicate to a separate data center for a slight amount more in fees.
So if you were in an environment that you did not have a network connection, and you were running your database locally with a virtual machine, once you became connected to the network, then it would replicate up to the storage.
Yeah, replication, you have pretty much have to deal with yourself. I mean, there is a SQL data set that can do it for you. You can upload data manually, but it's not really an automated thing. And you probably want to go over it. So you can either upgrade, like BCP uploads, or kind of do a VNet, do a VPN and upload that way, or just configure a raw data set. But it's still, you've got to do the work. So talking about the storage, so we haven't actually talked about it so far. But except, well, we've talked about that there is a storage service out there. So Azure's got a storage service with 3 main capabilities. The easy one to understand is queues. This has got a simple queuing system that's really intended for having a front end and a back end and using a queue to link the 2 together. It's a very easy to use queuing system. It's more like just put message, get message, put message, get message. And it's a best effort first in, first out. So that's pretty much all there is to it. It's very easy API to use. There's a table storage, which is a NoSQL store. So it's basically you create a table. There's no schema. Every record can have a different schema, etc. So it's a fairly easy sort of to use key value NoSQL store. These things scale up a lot. So a single storage account can have 200 terabytes in it. Then you can have multiple storage accounts, etc. And typical performance for the table storage is the scalability targets are 20,000 operations a second. And it does auto sharding, so you don't need to think about sharding. It looks at essentially the primary key or the partition key, and the storage service itself does all the data sharding behind the scenes. For both queues, and for a queue, the shard is actually the queue name itself. So a single queue can get 2,000 operations a second. Table goes up to 20,000 operations a second. Then the third one, which is one of the biggest ones, the one we've talked about so far, is the blob storage. There's 2 types of blobs, block and page. Block blobs are actually the most common, and they're really just files, the file storage system. And they're called blocks because if you have a large one, if you have a blob more than 64 megabytes, you have to upload it in blocks of 64 megabytes. So, but you can go up to 200 gigabytes, the largest size of a blob. And it's really intended for like media files, just raw files, where you essentially start with the linear file and read through to the end. And you access them, the underlying API to access them is all REST-based, but there's client libraries and a bunch of different languages on top of it, .NET, Node, etc., Java. So you can just upload files. And a lot of the demos you'll see like file uploading demos. I think we don't have to really show this. There's like uploading photos. And these photos are uploaded into blob, etc. So you get a simple workload might be, you have a website, you upload something to a blob, and stick a message in the queue saying process the thing in the blob, and then a workflow behind the scenes to get the message and do the processing. So you might take a photograph and make a thumbnail out of it. It's a kind of a fairly canonical example of that kind of website uploads, message in the queue, photo in blob. Worker will process the queue, makes a thumbnail, and then you get the website, you get thumbnail. So that's kind of an easy example. The other use of blob storage is page blobs. And the canonical use case of a page blob is the backing store for a VHD. So page blobs can be up to 1 terabyte in size, and they're intended for random access. You can write them anytime you want, as long as it's 512 byte pages. But typically people don't do that. I mean, you can certainly do it if you want. But the primary use case for a page blob is backing store for a VHD. And the VHDs can be attached to PaaS cloud services or IaaS cloud services. But really, even then, the PaaS one is kind of becoming a little bit deprecated. And so the main focus is IaaS, is to drive for IaaS. So it's the remote attached storage from IaaS. So when you bring up a virtual machine in IaaS, it'll come with 2 drives off the cuff. It'll get a C drive, which is a blob storage, like 127 gigabyte drive of blob storage, and it'll come with a D drive, which is physically attached to the server. It's really just meant for temporary space and kind of like local caching. And the difference is if the server gets blown away for some reason, or if the server does anything, it might has to move it, or you shut down the server yourself, the D drive is completely lost. You will never see the contents of the D drive again. They're holes. The C drive is in blob storage, and when you bring the machine up again, or Microsoft brings it up again, as the server really moved, the C drive's there. Anything that was written to the C drive and flushed through to storage will be available and bring it back up and down. So you don't lose any of the data on the C drive. Then you can attach up to 16 1-terabyte drives. These drives are all stored in blob storage. You don't lose the contents of them. The number of drives you can attach depends on the number of cores pretty much. So it's basically 2 drives per core. So a small instance with 1 core, you can have 2 additional terabytes of data drive attached to it. One of the things with page blobs is it's a sparse storage system. So a block blob, if you have a 200 gigabyte block blob, you will actually pay for 200 gigabytes of storage. A page blob is sparse storage. You don't actually store data stuff in use. So if you go and create a 1 terabyte page blob and you put nothing on it, you won't be charged any money whatsoever. If you start writing to it, you will get billed for it. You'll get billed for the individual pages you use. So if you just write 1 512 byte page, that's all they get billed for. So you can create a 1 terabyte drive, attach it to a machine, and do a quick format. A quick format pretty much just writes a partition table, and it's got a 512 byte PHP footer at the end of the file. So you won't really pay much for that drive. Even though it's 1 terabyte, you not really pay for like a small amount of used data for an empty drive. And the recommendation Microsoft gives is actually to do that, to create a large drive and just do a quick format. One of the benefits is if you're using a modern operating system like Server 2012 or Server 2012 R2, Microsoft has put what's called trim support. Trim is coming from the SSD world, whereas with an SSD, if you want to write, if you've deleted a file from SSD, it doesn't really do the delete. If you want to write to that space again, you actually have to clear the space and then write into it. And there's a feature of SSD drives instead of importing into regular drives. And so the issue with page blobs is you've created a big file, so like a 1 gigabyte file, and you delete the file. It just modifies the partition table, but drives typically don't actually clear the data. So they've added trim support to Server 2012, so you're using the drivers, the blob store drivers for Azure, it will actually go in and clear the data. So you won't build any more for that data. And if you look at the if you go out and look at the Explorer, you'll see an option like clean up the drive like once a week. So there's some schedule. I think it's typically once a week it's set, and they'll actually really go in and kind of clean the drives and delete the empty space. You can actually reconfigure that to do it more frequently, like on a daily basis or whatever. So there is the support, the trim support is in there now to clear off empty space and stop it being billed for it. Because until they did that, if you sort of created lots of big files and just deleted them, they're still being billed for the file even though you think it's been deleted. So these page blobs are the backing source for VHDs used for IaaS and also for VHDs used for PaaS if you want to do them. But so the C drive and the E drive, F drive, and so on are all stored in blob storage in these page blobs. You can download them, as Bruno said, you can actually take a VHD and download it to your on-premises, or do it on-premises and upload it if you want. So you can go to any direction, they're completely portable, they're not in any special format. And you can use things like regular storage instead of rapid storage just to manipulate files and move them around, copy them around from data center to data center.
Good.
That's a quick overview of storage. And really the point there is that all of the main data drives, other than the D drive on the virtual machine, are stored in storage. You do not lose them if you shut down the server or delete the server. You can in the portals, one of the options if you try and delete the server, it will like to say, do you also want to delete the drives? And if you've just got a thing, you just play around it. You can say, yeah, delete the drive, and all the data will be gone. But if you want to just shut down the server for and go back the next day, just shut it down. Maximum will blow away the VM, and it'll leave the storage for you, so you start it up the next day. And storage is pretty cheap. It's, I think it's like 67 cents a gigabyte. There was big price cuts last week, so everyone's kind of prices. And storage was particularly aggressively repriced. So I think it's like 5 cents or 6 cents a gigabyte per month for storage. And there is a storage operation charge, something like $1 for a million storage operations, something like that. So it's It's not that much. And typically, if you're running compute, the dominant charge is compute. Because if you think it's computers, we're talking just like 6 cents an hour for a VM. That's pretty much 12 cents. 12 cents would be, well, 6 cents an hour is a gigabyte storage per month. So you can get 1 VM or 1 gigabyte basically for 6 cents.
I kind of diagrammed a little bit of this. This is like the guestbook app that you're looking at. It's a little slightly different, but it kind of gives the concept. So let's say you had an on-premises cluster that was encoding videos or whatever it is you're doing. Well, you can easily move that to the cloud as we described by building up a couple of VMs. But the storage system, I guess, is the key point. You know, when you think about Windows Azure Storage, here I've got blobs, maybe that represent the unprocessed video. You might have video that's been encoded to MP4 or MPEG. And you might have Azure tables that store those attributes. Can I use SQL Server for this? Yes. Why would you use Azure Tables over SQL Server? Cheaper. Good one. Faster. Unstructured. It's a good way to think about this. So one of the ways I think about Azure Tables, it's a collection of objects. And our guestbook application has that. So in other words, if I go to the guestbook app, I haven't run for you yet, but I'll do so later. This is an object. It's called guestbook entry. Let me try to make this full screen. So this is a full-blown object. So each one of these is a row in an Azure table. Think of it as a row. So the columns in that, if you want to use database vernacular, the columns are message, guest name, photo URL, and so on. But notice something, and Neil kind of alluded to this, the partition key and row key are essential. You must provide that. Why? Because it determines the way that queries are executed efficiently. So if you have a where clause in your queries that account for both partition key and row key, and you're returning one record, that's the fastest possible query on earth. And it could be billions of rows because the way the system partitions the data across multiple machines is using the partition key and row key. So think of those as the primary key in a database. But also remember, you can't do joins here. You can't do joins. So you might have scenarios where you have multiple tables that have redundant data. In other words, highly denormalized because you're looking for performance. You're not looking for transactionally consistent relational data models. And notice, for example, this is a terrible partition key unless I plan to do queries that leverage month, day, year, and CPU ticks. Right? So a more realistic one might be email address or company as the partition key and maybe email address as the row key. Right? Because those two have to be unique. Can I read a table from a non-Microsoft? Of course, it's REST again. You can read these in any environment. But there is an API, and I'm looking at it. In fact, the Azure API has me inherit from table entity. That's what makes this an Azure table. So imagine a world where later I come in and I say, you know what? I want to also track user. Well, I can just add that here. And then you might ask yourself, well, Bruno, you already have a bunch of records or entities, they call them. Entity is what you would call a row, that don't have that. How could I just arbitrarily add and subtract attributes from my entities and still add to the same table? Well, that's why you think about it as a table of objects, a list of objects, and each object doesn't have to be identical. I think it would behoove you to start playing this game, to start playing with the entities, because now your queries are going to get lots of nulls or missing information that you don't anticipate. You want to be consistent, but I'm saying it's not required. Like in a relational database, you've got to provide all the columns, even if some of them are null.
So it's actually no SQL.
Exactly. It's a no SQL store. A dictionary based name value pair. The name is the partition key, row key, and the value are the rest of these attributes. Question?
How complex can the object be? Can you just basically
It's basically a set of name value pairs. It can be up to like a megabyte size. And the main core .NET type like strings and dates and stuff like that. But it's literally name value pair. It's no kind of, because if you want any substructure, you have to implement that yourself.
When you say substructure, like for example, you got a parent-child collection related to these.
So we go back to the partition key up at the top. The partition key is used for allocating data to different, that's the shard key. So if you've got a small table, the storage service might put it all in one server with the two backups. So everything's stored in triplicate in all the storage services. But you don't need to know that because that's just behind the scenes. So if it's a small table, it might all be one server. But if you get more and more data in, Microsoft will start moving chunks of different servers. And they'll do that by partition key. The partition key is the shard. We guarantee that everything with the same partition key will be in the same server, in the same node. And you can go up to full size, all 200 terabytes, which is 1 million. But it does reserve behind the scenes, you can't move it. So the problem that runs into it is if you have things with two different partition keys, it could be a different server. So if there's things so there is a concept of transactions, limited transaction support, but everything has to be in the same partition key for that to happen, because otherwise it can be different servers and it doesn't work.
Right, I was wondering, like,
So,
you know, got that parent view, it's got some properties. In this case, it's not like you're having like a relational
yeah,
table.
so,
with two tables.
so
It's all-
the solutions there are, the two solutions, one is to have basically all of these in the same table. It's different entities have different fields.
So my question specifically is the limit of 205 properties on a table. Does that include also all of those file properties?
No, the way to do around that would be two different records, one for the parent and one for the child. There'd be two different records in the same partition, in the same table.
Oh, I see. Yeah, you don't actually have all of this similarly.
But multiple. So one solution is to have just every entity is different. So it might be a parent and child are all the same entity, or you could have a parent and multiple children all in the same partition key. Because then you can do that transaction I was telling you about, and you can create it. And the code on the back, the code on the client side can deal with that. You can bring back a dictionary. You can bring back a structured type. But when you bring back type, it's this type or that type. But you can also bring back a dictionary, and then you can handle the dictionary. So you get the benefit of transactions and the locality by sticking all the same data. So there's a lot more flexibility, and people start thinking of those SQL stores and the tricks like that. So you don't have to, you don't think you normalize, you might actually under-normalize data and actually just sort of replicate the data and different data. It makes life easier from a query perspective. Yep.
So how complex, I think you right, how complex can this object be?
So a single entity is just a set of name value pairs. There's a small number of data types available.
So if I, for example, wanted to add company, and then this object, is that
If you want to add,
if I wanted to add another object to this structure, called
yeah, so you can only add the basic .NET types like string and integer and stuff like that, date types. So you can't do sets. If you want to have a set, you have to manage that yourself, which you can do, and you have to do it yourself. There is no set capability, for example. That's not saying you as a client couldn't just stick a set inside some string or something, but you would have to handle it yourself. The storage service just handles a small number of very basic dates, strings, like some number, like up to a megabyte per record. Yep.
binary.
Yeah. I think it was binary. But if you want to binary, you can also put stuff in block storage. Just to maybe point back to it. So that's one technique, for example. If you've got a message you want to stick in a queue and it's vague, or you want to put something on a table, is to store the large thing in blob storage and have a pointer back to it. So you can have a message to a small message in a queue pointing to a vague image in storage. You don't need to do big things in a queue, and you don't need to do big things in table, or even SQL Server. Like, one of the tricks is to try and pull as much data out of SQL database or SQL Server as you can. That's a very expensive place to put stuff. It's much cheaper to put in storage service. But using a new app, try and put as much as possible into the storage service and not the SQL Server. Yep.
So when we are actually getting a shared access signature for a blob to download, is that the expiry time that we actually specify, does that have to be the time that it takes to download the whole blob, or is it just for the connection?
I think it's just a connection. So this question was, we haven't really talked about authentication for the storage service. The way the storage service authenticates, we create a storage account, and that's got a universal and unique name across the whole Windows store. And that storage account name becomes the prefix to the URL we use to access it. And the client library knows that. So you get a storage account name and an access key. So it comes with a pair of access keys for the key location. And you can change them anytime you like. But you have to know the storage account name and the key to use to access the storage service. So that's the basic way. Then you can also create what's called a shared access signature. And that creates a time-limited query string you can use with the APIs to access the storage service. And it's controlled. You can say read-only access or whatever, or write-only access. You get some level of control. So this shared access signature is typically valid for a different amount of time. So for example, you might have an application that you want to download books. You might want to sell books and you want to have people download it. You could give them a shared access signature, and that would be valid for like an hour. So you could 1 hour is valid to download the book. And the question was, when is this checked? I believe it's just checked when you connect the first time, but we can probably check that if you really want to know. So I think it's just the first time you connect the check the shared access thing, and then it keeps downloading it. So you can, in order to create a shared access signature, you need access to the original authentication, the access key itself. So you can't just randomly create them. So it's basically a proof that whoever created it has access to the key and is authorized to use the service. So the shared access signatures works across all of the storage services. It's good for devices. So if you want to access the storage service for a device, you don't really want to give people access to the credentials because they may hack the service and steal your credentials. So you typically want to proxy it and give them a shared access signature valid for some amount of time, and you can then they can then use that with the credentials. So you typically do not want to ever put your secret credentials on any device in case someone steals it. You want to process it on the web API, give me a shared access signature that I can use.
You could make everything public if you're brave, right? You can just, because all blobs go in a container.
So that's actually an important point. So if you've got a website, so you could store, like an IaaS, you could say a web role with a website, you could put all of your images on the box. You can park it in your package and have the IaaS processing all the static images. The alternative is for all of the images, static content in the blob storage in a public container for read-only. There's a public read-only container. And so all of the traffic, because the images are coming out of blob storage, are not impacting your compute. So you're not paying compute to just upload it, to download a static image. So you can, that's a pretty standard way to do it. Media services use the same technique for just Microsoft's sort of media downloading service. So all of the data goes in blob storage. It does not impact your compute. You're impacting Microsoft's compute, but not your compute. You still pay egress charges, and you still pay the storage charges, but it doesn't impact your IaaS. You don't need to get an extra IaaS box just to run images out of it. Blob storage is a perfectly good place for images. Unless you want to secure them and lock them down, then you can do shared access.
And I think this is what you're talking about, Neil. I could go directly to storage from as a user. I probably don't want to do this. Why not? Why would I want the user to go directly? Why not just go through a service? Because you're burdening your service with unnecessary I/O. Let the user go directly to storage and offload. That means you need less scale on the web service. And to give you another example of what I've done on my blog post, like you see this header, you see this modern little box here. If I go and look at the code here, and we take a closer look here, notice it's pointing to my Azure. So that whole piece of table is this one right here. So if I go copy, and I go into a browser window here, and paste that in, you'll see that block just comes up.
And another thing you can do with blob storage is Microsoft has a CDN service, and you can point that CDN at blob storage, so you can get the benefit of local geographic distribution. And for those who don't know what CDN is, Content Delivery Network. So there's 10 data centers around the world that Azure has, but with a CDN, it provides local points of presence, local caching, so the static content like images, and you have a lot of users around the world. They would, even though normally it's going to blob storage, it would actually you would actually reconfigure and provide a CDN endpoint for that storage. And the CDN, so they would go to the local cache. So there may be a CDN endpoint instance in Mr. Rhino, or there may be one in Sydney, Australia. So there's an Australian user, instead of having to come to US West, you would end up getting the data from a cached copy in Sydney, which is much, much lower latency than coming all the way to US West. And then that cache copy can be updated periodically or automatically. You may say refresh the cache every day or every 3 days or whatever. And so as of last week, there's a CDN in general availability that Microsoft provides them, and it can go directly into blob storage. You can provide low latency access to static images, static content for websites.
Yeah, that's how I'm using it here. Notice it's called keylinks.html. It's Turkley blog content up here. So I bet you if I go into, say, Visual Studio right now, Guestbook, and I say view Server Explorer, kind of a key thing to know about, that lets you browse your storage, among other things. So I go to Visual Studio, Server Explorer, expand this out, go to Windows Azure, go to Storage Accounts, Storage, let it refresh. It's going to the portal now, and look at that. Turkley blog content is there, and one of the blobs is a container of what? Let's go back and look. The container name is blob calendar content, and inside that container is this keylinks.html. So let's go look at Server Explorer. So there's Turkley blog, and a double click. Hey, look at there it is. So Server Explorer lets me go look at all my blobs. It even gives you the URL over here. So if you look here, you can see the full URL. And this container is public. So that means any of you can go grab these URLs as blobs. And don't think of a blob, it has to be a video. It could be CSS, it could be JavaScript, it could be anything you want it to be. So I think this is a great way if you have static content on the web. What I do is I have a program called Cloud Tools, and what it does is it goes over here to my blog post, goes to a database where I have all this stuff, generates the markup using the database values of my events, and then uploads it automatically into my storage account. So I just click one button after updating my database, and my blog gets updated with this cool looking table. So just a use case of what I'm doing with it. So Neil, did you want to talk anything? Let's maybe go over a couple other quick things about storage here that I have in my blog post here about the use cases are write-heavy workloads, storing objects, indexing large documents, pages on high-traffic websites like I just showed you. When SQL Server can't scale anymore. Not supporting complex relationships, which was one of the questions we kept getting. It's not designed for that.
Yeah, the real thing is when you distribute, especially if you're thinking you're going to get very scalable service, is to sort of put it in sort of the most cost-effective way that scales well. And you should definitely, anything that you look at on-prem you might think of running a SQL Server, you should look and see, are there things here that aren't really relational, that don't have complex joins on, that we could put in table storage, or even put in blob storage. Why store a blob in SQL Server or SQL database when you can do it much cheaper than blob storage? It's a system designed for storage of blobs. So try and move things out of SQL Server if you can, because you get much more cost-effective, much more scalable, much more performant system if you put things into table storage or blob storage and move it out of SQL Server, because they scale like. So the example I gave, SQL database, the managed version, the PaaS version of SQL Server, It's not normal, it's definitely a horizontal scale and performance model, but it's $10 a gigabyte, whereas table storage is 6 cents a gigabyte. And you get more performance than table storage. What you don't get in table storage are complex joins. The query capability is very limited, but you do get the high scale. NoSQL stores are pretty common. There's all these MongoDB and Cassandras across the world. Everyone understands the value of NoSQL stores. Many of them are relatively consistent because you're right, and because they're replicated, readers may not see the same data immediately. Windows Azure storage team made a conscious decision. Everything is fully consistent. If you write, all readers will see the same thing. They're not eventually consistent. So you don't have to worry that program. As a program, you have to worry about the eventual consistency. Someone had a question.
Yeah, I was about to query. How do you query on fields and columns which are not part of
yeah. So the issue is the only index on table storage is the partition key and row key in that sequence, and it's the data is alphabetically indexed. So if you do a point query with partition key and row key, it's very fast because it just literally goes straight to the server, grab the data. If you provide the partition key, that and nothing else, that tells the system which server to go to, which node contains the data. So it's relatively quick. If you provide the row key, it pretty much has to table scan because it doesn't know, it has to check every partition for that row key. Really what happens is the row key provides uniqueness within a partition. If you don't provide either of them, it's going to table scan all over the place. So you really want to think about queries, perhaps denormalizing data and creating your own secondary index. So you might write the data to one table and then write a second table that is an index to the first one for non-primary keys. So because the storage is so cheap, it's relatively cost effective to write your own indexes if you have to duplicate the data. There's less of a focus on perfect normalization of data. Oftentimes it's write once and read many. It's not intended really for kind of continual update of data. So you might be writing logs and stuff like that over a period of months. So definitely, you shouldn't think of writing logs in SQL Server. You should typically you write them once, you never update them ever again. And that's the kind of data that's really good for putting in storage. And if you do want to query it, kind of do re-indexing and write it multiple times.
So you can see here range queries are slower, greater than or equal to. The one at the top, this is the fastest. This evaluates to a single record. Now where you get to be like the turtle and the mule here is where you don't have a row key. And here's the worst possible scenario in the world that Neil just highlighted. You don't even have a partition key. So that in the SQL world, that's like a full table store. So be careful. And what's the language we're querying in anyway here? What's this language? Link, right?
So there's multiple. They've modified the storage library, the client library. So the raw stuff is always REST. So when I tell people you want to know the capabilities, look at the REST API because it's a pretty basic API and it tells you exactly what the service can do. Because if you can't do it in REST, you can't do it. Then there's multiple languages like C# and Java, Node.js libraries on top. And the storage team's done a lot of changes. There's the latest version of the library. There's things like support JSON. Before it supported the Atom Hub. So you get an entity back with all this nice XML, which is very heavily documented. It was also very heavy. So they now support JSON, which is about 70% lighter. So that makes it much more performant. And so there's been a lot of speed improvements. So definitely starting to use the latest version of the SDK and think about using JSON instead of Atom Hub to format the data to get back from tables. You find a much more performant system.
Here's like a basic insert statement right here that this is Lab 2. I'm looking at Lab 2. This is adding. Lab 2 is awesome. Why is Lab 2 awesome? It's platform as a service. What else is awesome about it? It shows web roles and worker roles. What else do I like about it? It leverages tables, blobs, and queues. And it survived since the days Neil and I met years ago. This lab has survived the test of time. It's such an awesome lab. It shows all of it. Here's an example of how you would create a new entity. Whoops. How you create a new entity. And then here you can see we instantiate this data source over here. And then we insert the entity. That's it. And notice the attributes are getting assigned right here. Guest name, photo URL. It just comes from the web page.
There's one other thing in this particular example. If you look at the bottom, it's the system.diagnostics.trade. So one thing when you run in the cloud, you're running distributed systems, and maybe a lot of servers. It's important to document everything and log everything. I got some training from the Azure CAP team, which was in for a Microsoft special team that goes into sort of the really large customers and fixes the really large problems. And they say if you don't log something, it didn't happen. We have things, we did the Baltimore website a few years ago, which is from the Harry Potter kind of fan site, the relatives, and Microsoft did it. That means that it said, we're with 300,000 trace messages a second we're logging. Obviously you can't look at that as a human, it's just impossible. So they do a lot of this, and the system for diagnostics can be used for automating the logging of your service. You can turn diagnostics on and automate the logging into Windows Azure storage, which then look at afterwards, and stuff like that. It's crucially important that you have to log, do a lot of logging, and Windows Azure diagnostics is the way to do that. And that system.diagnostics is part of that system.
What's the isolation level in this scenario? I'm assuming that it's within the machine that it actually runs in. It runs within some isolation container. So
for the storage service?
Well, on the server itself, right? So let's pretend that your service here is looking at Emerson queues. Right? So there's a bunch of queues on the machine. How is access controlled?
So the underlying storage,
I'm not the only thing running on that machine, right?
So the underlying storage service is a multi-tenant service, so you don't know other clients are running or using, and you have no visibility whatsoever. Right. So the access control is just through this part name and access key. So that's the control layer. You have no visibility whatsoever onto the underlying storage service other than that two keys.
So does that then mean that in the MSMQ scenario you don't have access?
Yes, so it's not MSMQ, it's a separate queuing service run by the storage team. So it's not as fully featured as MSMQ. The equivalent to MSMQ would be the service bus queue, which is a more lower end kind of queuing service. But these are multi-tenant services, and so Microsoft does all the tenant isolation for you. It's exactly the same as the VNet. Microsoft does all of the tenant isolation in the VNet. And you're all running the same virtual on the same level pipe. So Microsoft handles all of that tenant isolation. So it handles all of the tenant isolation and storage services. All of the services Microsoft handles that. And you have no access, you have no visibility into that.
I mean, your service has access to I/O, right? So can you pretend that you're opening a TCP/IP port?
No, you don't. It's very heavily locked down. So you can actually go to the Windows Azure Trust Center, which is a formal Microsoft public page for their official documentation on things like what the certifications are in terms of locking down, and you can have regulations for the health to privacy, and a bunch of other personal regulations and stuff. So they kind of, the compliance is done on this trust page. You just search like Windows Azure Trust Center, and you bring up a whole load of kind of formal legal documents, which are the only legal documents you're likely to get. At least pointers to them in terms of what the things they comply with, like HIPAA and PCI and all that kind of stuff. I think they're working with PCI. These are very, very isolated DNS. It's all private IP spaces. Everyone on Windows Azure can go do it. So you don't see it all. It's one of the core things any of the clouds to be on. So even though it's a multi-tenant service, you can't leave it for it.
Okay, so in a few moments we're going to have some lunch brought for you. How does the group feel about moving forward? Do you want to? Allergy season? All right, so did anyone get stuck in the lab? Did anyone, did you try to do the lab? Did you try to spin up some VMs? A couple of you did? Good. So what's the preference? Let's do some slides. So there's two main topic areas that we haven't covered, which would be platform as a service with the kind of lab that's there, and then Active Directory. So this slide is one of my favorites that you see right here. And it kind of distinguishes between, the different types of services. So if you look over here, the prepackaged software, this is what we were doing since the birth of computers, pretty much. We were essentially managing everything, all the way from the bottom of networking to the top, your application. Top to bottom, orange is the work you have to do. Green is the work you don't have to do. So when VMs were created, all of a sudden now you could rely on these pre-built images, and you ended up getting freed out of the virtualization, the physical servers, the physical storage, and all the physical networking. You just dealt with, maybe the operating system a little bit, patching it up, some of the middleware, the services that you add to it, the data, and so on. And that's kind of what part of the portal would be this second box here. What are we talking about for this one here? Where do you go from the portal for this? Please, one at a time.
Virtual machine.
Thank you. Yes, virtual machines. So that's infrastructures of servers right there. And then finally, platform as a service, which means what? I'm in Visual Studio, and I just write mouse click. I've got my app, I've got the data connections, and I'm done. And then some of you here, I just talked to Joe, he's a partner, and a lot of you guys are trying to offer this to your customers. And then you get into the multi-tenancy issue. So if you look at a lot of the products that are multi-tenant, like Exchange and SharePoint and all those products, and we wrote an article about this, right? The main thing here is how do you factor identity into an application so that no one sees anyone else's data, so that everyone's compartmentalized. And there's companies like Aprenda.com who lets you kind of flip a switch and make your app multi-tenant without having to rewrite it. So there's a lot here in the software as a service. So I think there's opportunity for everyone here that has the next big idea to create a service out of it. Which is basically what? An API you expose or a web property of some kind? Any questions about this graph? Right? So the last one, SOP means what? Your customers worry about nothing. The developer worries about nothing. It just goes and signs up. I mean, you could argue the Azure portal is this, right? It's software as a service in a sense. Okay, you know about the global footprint. Neil just enumerated a bunch of them. But it's really 3 regions, US, Europe, and Asia. So when you talk about geo-replication, it can't go across regions. So you can replicate from, say, the west data center to the east data center, but you can't go from, say, Washington to Singapore. You can't geo-replicate automatically. You could set up your own replication strategy, but we don't provide it out of the box. Okay, I already talked to you about that. Did the demos already. Subscriptions we talked about. So one of the questions I got was how do I manage a dev test environment? One of the things that Neil was talking about is you have one subscription for test and one subscription for production. And that kind of guarantees that wires won't get crossed. And also, it's the billing model, so you can kind of quantify things by subscription. So maybe you have a team that's doing data science at your company, and you want to know how much they're costing you, well, give them their own subscription. And then they can leverage all the different aspects of the platform. You don't have to segregate and add them all up. And I think, Neil, you were talking to me this morning about more and more Microsoft trying to have an audit trail about who did what on what machine so that you can ascribe billing. And I think one of the biggest challenges in the cloud is that if you ask someone, hey, how much is your 3-node cluster with 2 web servers and a database costing you per month in terms of everything? What's the monthly cost? No one can tell you very easily. They can tell you how much EMC storage is costing every month. They can tell you data costs, but if you ask them, how do you quantify your app, it's very difficult to kind of put a number on it. So I think that's another kind of hidden benefit of the cloud, is that you can actually calculate what things cost.
The new portal is actually getting a lot of stuff now with billing. It used to be kind of hidden, but they're kind of, I think, pretty much keeping up to date. You can see there's like pie charts of who's using computer storage, etc. I think a lot more of that kind of up-to-date billing information will be in the new portal.
So here is that new portal. It's quite a bit different, isn't it?
You haven't used any money yet.
I haven't played with it. This just came out last week, and you can see it links me to the old portal right here, I believe. So we got a whole billing tab here. So anyway, we're not here to learn the new portal today, but this is things to come. If you go over here to, say, journeys, billing's got this whole thing. The gallery is all the various features. Go home. See over here on the right, that's kind of familiar, isn't it? That's kind of how we've been looking at the portal. Okay, what else is interesting? Mobile services, we talked about that. We'll just go through it real quickly. I didn't have code snippets, but here's that script piece. So one of the things that mobile services does is it gives you code. So when I went and created a new mobile service, I can actually download a project for iOS. I can running in Xcode, right? So you can download an Xcode project with some Objective-C in there. You can download an Android app that you can load up in Eclipse. You can download a Xamarin file for Xamarin. You can do Windows Phone, Windows Tablet. Those projects are directly downloadable from the portal. So that's kind of a big deal. And one of the things that gives you is this. If you can see here, we have the to-do item. So this assumes that there's a database there with a table called to-do item. So I can literally go add an attribute to that table, to this code, and it will go and create this SQL Server table to reflect that. So it's kind of like an entity framework scenario where I have code and the underlying physical database, and I could alter the code and it changes the database. So notice over here the script tab. That means that when an insert statement happens on the to-do item table, I can put validation in there. I can go respond to the insert statement. And of course, delete, update, what you would expect. So again, this is, and it's no mystery this is JavaScript, right? Because after all, it's all written in Node.js. So this is Node code. Probably goes directly into the Node backend behind the scenes. Data and API, relational databases, I kind of got into that. API, let me just close my email so you guys don't see all that distraction. API, you can define operations for get, put, post, delete, and I'll show you some examples of that. So here's API. You can control who has access to get, post, patch, delete. Those are the HTTP verbs. Now, assuming someone has authenticated access to, say, a get, you can go in here now, and in this case it's a post, if you notice. When a post gets issued against the API, this method gets executed. And notice what this method's doing. It's going to go read from the HTTP body some attributes, the X and Y. It's going to read the operation. It's going to read the operation here. So it's going to parse what was passed. And the operation could be something like add or subtract. So I'm assuming a phone or a mobile device of some kind is doing a post to my mobile service, and in that post they're stuffing the header with information they want that JavaScript to execute upon. So this is how you extend your mobile service to add functionality to it. What's the alternative if you don't want to use mobile services? Go create an Azure website with Node in the back end. Go create a cloud service written in C# using the Web API or WCF. Right? This is just giving you one-stop shopping mobile services. It's giving you push notification. It's giving you back-end services. It's giving you a scheduler, identity, push notifications. That's the point of mobile services. I actually have a really cool demo I just kind of started putting together. Let me see if I can dig that up. I'm going to show this in Sacramento to a code camp. It's called Intro to Mobile Services. And here's what it looks like. Let me just show it to you. It's faster to show you this than to actually, so I'm going to have this on my blog post pretty soon. It's surprisingly complete. So the idea is I'm going to Visual Studio, do File, New Project, and I'm creating a phone app. I don't know if you can see that, but that's a phone app right here. It's a hub-style app, meaning on the phone itself, it's going to have a scrollable background, right? You can go scroll to the right on the phone device, kind of like the portrait mode. Once I've created my phone, no big deal, Visual Studio with a project of a phone. Wouldn't it be cool if I could add push notifications really easily? Well, it turns out you can do that. So if you notice over here, I'm going to right mouse click, add push notification. After that, it's going to tell you, it's going to do a bunch of stuff. It's going to give you a channel that you can communicate with to get your push notifications. It's going to create a bunch of stuff, basically, is what it's saying. So I sign in. Did you know that you can do this with identity? Anyone knows what this is called, what type of authentication this is called?
OTP?
Yes, multi-factor authentication. So you can add that to your app, so the person needs to have a valid cell phone to be able to log in. So the store does that. I'm logging into the Windows Store. Bruno, why are you logging into the Windows Store now? Because when I want to do push notifications, I assume that that app is in the store. So this add push notification is going to do a few things. It's going to reserve a spot in the store, and it's going to add stuff to my mobile services account. And it's going to modify the current project. It's going to wire everything up with one wizard. Remember, I'm in just the same wizard now. So I entered my code, and now it wants me to enter a name for my app. And this is the app, if I were to go to the store, it's called My Phone App. It's an app I'm going to sell and release. So I'm literally reserving the name at the store to guarantee I have it. And at this point, am I going to leverage an existing mobile service, or do I want to create a whole new one for this phone app? I'm going to choose, let's create a whole new one. So notice what I'm doing here. I'm going up to the portal, and I'm going to create a service called Service My Phone App. And I bet you if I go back to the portal now, I have that. If I go to Mobile Services, sure enough, there it is. Let me stretch this out. There is my app. Not only that, if I drill into it, notice I've got push all set up. It filled all this stuff in for me. In Visual Studio. This used to be things you'd have to wire up yourself. By the way, if I go back and drill in, what do you notice over here? Those all give me projects. So if I want to run an HTML project, it gives me the source code for that. Windows Store, Phone, iOS, Android, Xamarin, and PhoneGap. So if you click these, it'll literally let you download a solution of code already filled in to talk to your service. So it's a major step forward as far as the developer is concerned. You don't have to start with file new project and it's empty. It gives you the project. So if I go here and I say, hey, I want this to be, say, a Phone 8 app, I can just download it. But I've already chosen this one, right, from Visual Studio. I didn't do it here in the portal. I could do it in the portal, but I'm doing everything here from Visual Studio. That's the idea here. I don't want to bother with the portal. I want to stay in Visual Studio, wire everything up here with my back end and my front end all in one place. So we set the password. You can see now the service is created. And it's telling you all the things that it just did. Adding references to the mobile SDK. It set up all the logic for push notifications and so on. You go in here and you can see it added code to your project. that's where I left off. I think I actually have this here hiding somewhere. Let's go find it. Phone with push notification. Here's the project. And you can see it's just, I haven't like explored deeply into this yet. I just literally got to it. So you can see it's got the connection to the database figured out for you. It's giving you some basic properties to work with. The idea here is this might be part of the data you're storing of your data source. At any rate, the point is this, that mobile services kind of manages all these different pieces itself. So the API is different than what I showed you. It's not push notification. Is you want to allow this web-based API to interact with your service. So here's the add operation. The scheduler, maybe you want to remove some old records, look for dupes, do something on a schedule. Email people, resize images, and you can write script to do that. Push we just talked about. I think the easiest way is to go and do this from Visual Studio, not from the portal. And identity, how do you want to log in? There's the database part of it that gets wired up for you, and that's that. We talked about the database world already. Anyone have any questions about SQL database as a service versus the virtual machine SQL server? Yeah, we talked about this, demoed it, and everything. Cache. So this means this is a cache that takes memory. It's not a dedicated cache, it's a shared cache, so distributed cache. So your individual process in the web role, we're talking about cloud services here. What do you tell people when they say, hey, does this work on virtual machines? Nope. I was hoping you'd say, well, if you do X, you can. So this is for platform as a service, basically.
Microsoft's actually it's had a number of iterations of a caching service. It started off with basically the on-premises velocity caching service. It kind of did a hosted version. This is like 3 or 4 years ago. So they just give you an endpoint, and you could use that endpoint for your cache. And it ran into a number of problems. One is people thought it was expensive, and the second is that you get throttled if you use it too much. You pay for a given amount, and you're over that amount, you get throttled. So caching, which you run out of cache halfway through an hour, isn't very good. You get 30 minutes to wait for no cache. So then they come up with this system in which you basically, if you've got a cloud service, a PaaS cloud service, you can either do an in-memory cache, you can share some of the memory in your web role if that's all you have, add a few extra instances and share some of the memory in the web role, or you can actually have a dedicated cache. You can have a specific worker role that Microsoft will just add into your project and run the cache on that. Basically, it's all run for you. It's really just a kind of an extra role that's running in your project. You don't have to do any work for. And from anywhere inside that PaaS cloud service, you can access the cache. And that was actually pretty successful. It's unique to you. It's not shared with anyone else. It's your service. If you want a 100 gigabyte cache, you could spin up, I guess, 10 extra larges or something, because you could get 10 gigabytes for an extra large machine. So Microsoft had customers with 100 gigabyte caches inside the cloud service. That one, the problem with that one is that it was only visible within a single cloud service. So if you had an IaaS cloud service, you couldn't reach it, even though they're in the same VNet, there was no tooling and no capability to be able to reach into the cloud service and access the cache. And so Microsoft now come up with a new service that's, I think it's still in preview, but it's again a central service, but more or less Microsoft spins this up for you behind the scenes. You get your own dedicated cache managed by Microsoft, and you don't have to add an extra role. They do a lot for you. So I think that's really what the future is going to be. Because the benefit of the central one is that A, you get dedicated VMs associated just for you, so you don't share it with other people. And B, it's available from anywhere. If you have multiple services, you can then access the same central cache. You don't have to, I work with people and they have to do tricky things because there's multiple cloud services and they couldn't share the cache between them. It was unfortunate. The new central cache you can share among your services, including IaaS services. You can't reach, so So that's kind of where the future's going to lie, I think, because A, you don't have to, it's not part of your cloud service, it's fully managed, etc. And it's got memcached support, so if you really got an app using memcached, you can use the same protocol to get to the new one, or even the one we were showing here.
So besides performance, why else would you care about a cache? Are caches lowering, can they lower costs? They can, right? So you can minimize the amount of data leaving a data center by using a cache.
And it's also for stability. Like if you do something wrong, it's gonna still for like half hour move from the cache, so you have time to fix the things on your end, right?
Interesting, I never thought of it that way.
It's a very good point. Like you can pull that things from the cache.
Interesting. And you can scale this as much as you want.
You said that you're reducing the cost because it's not going to be in the data center. So
think of like, say I got a virtual machine that's talking to a blob in another data center.
Right.
And so if that machine can just use a local cache version of that blob, it doesn't have to go to the other data center to retrieve it. So that can reduce the cost.
You're saying this is a centralized cache, right? So that means any data center from anywhere can access this cache.
Well, you probably you don't really want to reach out to a different data center for
Right.
cache, because you'll have huge latency problems. Because you want low latency as part of the cache, it's the core feature of the cache.
So basically,
what it save you-
it synchronizes the cache across all the data centers, and so
You would have to do that yourself.
oh, it's not. This doesn't do
No,
it.
it's a central service run by Microsoft inside the data center. You don't want to reach across. Where it can benefit you, try and avoid kind of performance issues of going to persistent store all the time. Because there is there's a limit of how much traffic you can put into storage account, 20,000 operations per second. If you're going to exceed that,
Right.
one way is if you can stick a cache in, then you're not making the calls at all. So you can make your application more performant.
Right.
And it's all within the Visual Studio tooling. So if I go back to our guestbook application and I right mouse click on the web roll and say properties, you can see there's a caching tab here. Again, a platform as a service feature, not a VM feature. I imagine we'll figure out how to add that to everything else.
So this is the one Bruno just showed. That's the one that fits in the role. There is the central one. It's kind of the newer version that is accessible to any service. You can access it on IaaS.
How's it can't get updated? Is it
You have,
static
yeah, you
cache
have.
or-
Well, you have to load it yourself. You completely manage the cache. When you manage the data in the cache, Microsoft has no clue what you want. So if you're bringing a roll up, you might want to sort of warm up the cache and put data into it, or kind of do write through things like that, write to the cache and write to the data. So it's not completely up to you how the cache is populated.
Is there an API you can use?
Yeah, and it's good. The velocity API is pretty simple. I mean, most of the caching stuff is fairly simple, but it's like put and get basically. And so there is the velocity one, the Microsoft one, has got both optimistic and pessimistic concurrency. So you can more or less with pessimistic you can take locks. Theoretically, you can take a lock and stop other people writing to it, or you can just kind of look at e-tags and see who's got the most recent write, who's got the most recent e-tag. So it's got either this e-tag based optimistic or locks.
Okay, excellent. So identity. Service bus is another feature that I think is underappreciated. So I think what I'll do is I'll point you to one of the articles I wrote about this on the service bus and gave you a pretty solid use case scenario of why you would care about the service bus. It's kind of not fully understood in all cases of why it's important, but here's like a little diagram I drew for this article. So imagine that you have a bunch of Arduinos or a bunch of small machine-to-machine computing scenarios, and what's the problem with a lot of these modern networked devices is that people grant them privileges to a VPN. And if these aren't in your physical control, if someone compromises the physical device, they compromise your network. So how do you have this thing communicate up in the cloud and not really be part of the VPN. And so that's where the service bus fits in. The other problem is these devices are short on power, so they typically go to sleep until their buffers fill up, then they wake up and connect. But what you can have them do is go connect up to the service bus, and it's like a queue. So you can go up there and put messages and read messages from the queue. If you look later in the article, they kind of show you how that might work. For example, you might have what we call a subscription. So building 1 might subscribe to temperature, and it might subscribe to shade, whereas building 2 might subscribe to something different. So the Arduino device would put things into the temperature queue or put things into the shade queue, and those are topics. So the way the service bus works is you subscribe to topics. So the Arduino would write to a topic, and some other entity would subscribe to that topic. So it's a way for you to implement the pub sub model. So if you want to broadcast one message to a lot of listeners, the service bus can let you do that. So that's one of the things it lets you do. The other thing, it lets you act as a relay. So I can have my laptop connect up to your laptop directly, and I can send you files and information directly through this relay. And if network conditions permit, it can upgrade us to a direct peer-to-peer connection, much like Skype. So that's useful for medical scenarios where you want to send information maybe through the cloud, but you don't want that information ever to live in some central repository. I had a guy up in Bellevue that took this lecture and made a business out of it. He went to medical offices and he started, instead of a fax, he used the service bus.
So one of the differences, so you've now heard 2 queuing systems. One, I briefly introduced a storage one earlier on, which says put message, get message. And now they've got service bus queues, so why would you use, when you would use either one? So the service bus...
Can't hear you very well.
I'll turn it on. Down.
Let me turn it up a little bit.
So the question is, when would you use storage queues and when would you use service bus queues? Because I mean, they're both queuing systems. You put a message in the front, you put a message on the back, and pull it off the front. Can you hear me now?
No. It's not working for some reason.
No.
Here, how about this guy here? Shut that off then, after the feedback.
So when would you use service bus queues as opposed to storage queues? Can you hear me? No. Good luck. I have a speaker.
Okay, try it out.
Can you hear me?
Yeah.
Hey. The storage queues are really intended as a kind of very easy to use way to queue data as an intermediary between a web role and a worker role. Especially if we're already using storage, this API is the same as it is for the other storage services. So you don't need to sort of learn a new API and learn new stuff. It's all the same things. So it's very basic, first in, first out, messages last a week, they've got a given size. It doesn't have much more sophistication than that. Service bus queues came out of a sort of more middleware market. It was much smaller queues. The storage queues could go up to 200 terabytes a queue, whereas storage queues, the service bus queues were 5 gigabytes. But the messages could be much larger. And it was built more with an idea of kind of traditional MSNQ style messaging. So you can get things like poison message queues automatically, dead letter queues, if a message is stuck there too long, and put in a special dead letter queue where you can then process it after the fact, or poison messages can be kind of put in a special queue and handle that. It'll also do things like session management, so you can actually have a whole bunch of messages associated with the same session. Kind of have, like, if it's a lot of information you want to pass, you can put them in a session. Or you can have a session associated with an individual device. So if you're doing this Internet of Things kind of scenario, instead of having one queue for every device, you could have one queue but then have these sessions, and a session would relate to the device. So all the messages from one device would go into a single session, and a reader can just keep reading through that session. So it kind of gives you like a sub-queue capability for Internet of Things. And at Build last week, I think there's only the two talks of Service Bus. One of them was kind of an Internet of Things, the other was how to scale Service Bus. And so Service Bus, in order to make it scalable, has done things like allow paired, you can now have sort of multiplex Service Bus queues together and have a virtual front end and have many queues in the back end. As Bruno alluded to, it's got this topics and subscriptions. So there's actually two variants of Service Bus. One is just a basic queue, which is messages go to the back and come off the front. And the team recommends you basically don't use that. But you instead use the more sophisticated topic and subscription. What that is a topic is like the front end of the queue, and you stick message in the topic. But then you can have multiple subscriptions on the back end and multiple competing consumers for each subscription. So an easy example would be you could have a subscription for West US, a subscription for East US, a subscription for Central US, and then an auditing subscription that sees all the messages. So, and you can have different consumers grabbing messages from each of these subscriptions. So it's a way of kind of filtering and processing the data in a more sophisticated fashion. And this is one of the uses of the Service Bus is queues is you can put a message into, you can put text into the message, but you can also do a lot of metadata. And a fairly standard use is actually to only use metadata, not actually to use the content of the message. By using metadata, you can do things like have the messages can be filtered into the subscriptions, or you can kind of modify. You can say if different clients are sending in, you've got a version 1 client and a version 2 client. You can inside the Service Bus itself, you can change the message content. You can change the message metadata and kind of align them so the consumers only see the same data. So you might have changed some of the message metadata. And the Service Bus itself can handle that. Gives you the ability to do some limited modification of the messages passing through the system, whereas the storage queue can't do. So the Service Bus queues and topics add in this kind of more sophisticated behavior, correlated messages. The client sends a message to the server, and the server can send one back to the client and kind of put content in the message so it knows where the clients know which one to pick up. So a lot of that kind of more sophisticated middleware stuff is in. Downsides of the Service Bus queue is it's got other dependencies, like currently it's dependent on SQL Azure, so if SQL Azure goes down, you can lose access to the Service Bus queues, which doesn't happen in the storage. Storage is essentially a more reliable service, because it's only dependent on itself, it doesn't depend on other things. But it's getting a lot of excitement. Clemens Vastus, the main program manager in that team, is doing a lot of kind of blog posting and videos and Internet of Things, like using it for client devices, etc. So you get these, as I said, you get these two choices, and you get to pick them as a developer. If you your storage, you don't need very sophisticated stuff. Stick to storage queues because the likelihood is you're already using storage somewhere else, especially using table storage or blob storage. So you don't need to learn the API for Service Bus. But if you want the more sophisticated messaging capabilities, sessions and correlations and stuff, automated dead lettering and poison message handling, you can use that. It's also good, both of them have at least once semantics. That means you can get a message. The basic way to do it, in either of them is you get a message, you process the message, then you delete the message. So the message will be read at least once. It's at least once because if this VM processing the message dies, that message will become visible in the queue again and someone else can read it. So you've always got to be careful with messaging systems of idempotency, that the message could get processed more than once, including simultaneously. So you do have to be aware that you don't want to do things that are destructive because the second time might fail. So you're always trying to ensure that the work is idempotent. If it gets repeated, it's not going to cause any problems. The Service Bus queues and topics have an additional capability of at most once. You can just say, give me the next message and immediately delete it. And that's faster, but the issue is there, if the VM processing it dies, then the message is lost. So it's at most once delivery. And it's technically possible to arrange it to be exactly once, but you've got to do a lot more processing on the client side to do that. So these are kind of the rough difference in the technology between the two services. And you get to pick which one you use. They're broadly competitive in performance. It's probably easier to scale out the storage queues than it is the service queues to very, very high queue sizes, but you probably don't want that anyway. The Service Bus team's getting pretty active in improving performance for its queuing system. I think we'll see a lot more this year. that's the queuing.
Thank you. Yeah, so do we all agree there's two types of queues at a minimum? The service bus and then the regular storage ones that have been around for a while?
So the service bus doesn't have a guaranteed delivery feature like the message queue. Where a message delivered only once, no matter what.
To do exactly once, you've got to do work on the client side yourself. You've got to keep track of what's being processed. It's very difficult in a truly distributed system to do exactly once. And so they say you can do it, but you've got to keep track of what messages have been processed, etc. So it's probably, you should probably try and avoid that if possible in sort of a distributed system. It's kind of tricky.
We were talking with Stephen and I at the back earlier about how you might implement guaranteed delivery, and you might have two queues. So the client would read a message and then immediately post back to another queue, hey, I read this message. And then the sender could say, oh, okay, client one did see my message.
So you can, that's when they have the concept of correlation. There's a correlation ID can flow with the message and can flow back. So if, I guess if the sender doesn't get the correlation ID back, then at some point they can resend the message. So there are ways of kind of doing that. That's what the correlation is meant for, is kind of allow the sender and the receiver to at least have some communication.
Yeah, what were the size limitations you said? 5 gigabytes?
So it's 5 gigabytes per queue. I think it's like 200 kilobytes per message. Although again, if you've got big messages, you probably want to dump the data into blob storage and just for pointers. So then the storage queues is 200 terabytes.
200 terabytes.
But if you're getting up to 200 terabytes, you have a queuing problem. It's taking a while to process. And the service bus queues now has like this multiplex queuing system going there. You can have multiple queues kind of tied together, kind of a single front end.
On storage queue, 200 terabytes for the entire queue, but how about per message?
64 kilobytes for the content. And it doesn't really have the metadata capability of the other one. It doesn't have the filtering capability that the service bus queue's got. But again, if the message is getting big, you probably should really dump it into blob storage, just have a small message.
So service bus queues, as Neil was pointing out, larger message size, larger queue size, durable queues, no maximum time to live, peak and lock type of semantics, deduplication, polling on queues, and the pub sub, as we pointed out.
Yes, so the service bus has got long polling, so you can actually reach out and say, give me the next message, and it will just hang there waiting for the next message to come. You don't need to keep polling all the time. So that the storage queues doesn't do that, you have to keep polling. And you can get into problems if you just do a while next message on the storage queues, and there's no message, it's just gonna like max out the processor, and you'll, if you don't handle it properly and do back off, if there's no message, kind of backing off a little bit and then backing off again into those messages. And if you don't do that, you'll end up, the CPU is just going to go in this tight spin, just asking for the next message. And so you've got to, especially in the storage queues, you have to sort of start backing off if there's no message available. Service bus queues will do long polling and just wait for the next message. I think it waits like for 30 hours or something.
So there's the guestbook app actually demonstrates a lot of the things we've been talking about. This is the second lab, Platform as a Service, Introduction to Cloud Services. So the app is very simple. I'm going to see if we can guess the architecture of how it might work. So I'll say Bruno, and the message is demo, a feature. Let's go get a picture. How about a rainbow? We did that, so this is from like the, I don't know, this means send, the pencil. So I didn't design this. I reskinned this myself. So notice I've uploaded a real photo I took the other day. I didn't find a pot of gold, unfortunately. I might not be here. But watch what's going to happen in about 3 or 4 seconds here. It's going to be picked up by a background process and resized. So that just happened. So your question becomes, how did that work? What was the logic that just kicked all that off? And the logic is this. So here's the one I reskinned. I call that wacky photos, but there is no pencil button. So what I did is so the user uploads a photo through the web roll, right? Because that was a web page you saw, so that was a web roll. I uploaded the photo, and it's stored as a blob. The full photo itself is stored as a blob. An entry made in the Azure tables saying, hey, I just uploaded a blob. Web roll writes to the Azure tables. It also puts in the location of that blob into a queue. Why would it do that? Why would the web roll put in the location of that photo into a queue? So what background process can go and make a thumbnail out of it? So basically, this queue has the location of the full fidelity blob. Then the worker roll is just looping, reading that queue continuously. Pauses, reads. Hey, found something. It found a photo. So it makes a thumbnail out of it, out of that blob. It goes back to the table and says, hey, I'm going to update that row. Now I'm going to put the thumbnail, not just the full fidelity photo. That's what the Guestbook app does. So let's look at that Guestbook app, and I can show you some of those little pieces. Here it is. I'm going to dock this screen back up. So I'm going to go into Solution Explorer and show where those things are happening. So remember I said when you click Send on the, so let me just build this app a little bit. Notice there are numerous projects here. 4 projects in one solution. So maybe I can quickly walk through here how you would get these 4 projects in one place. So I'm going to start up a new instance of Visual Studio. No, because the background roll just loops continuously until it finds something in the queue. Yes.
How would this work in an environment where the load is so great that you have multiple workers reading a queue?
So let's say that the web roll is putting up so many photos that the worker roll can't process it. You would simply add more worker rolls to it.
Right. So now, what controls the worker is not picking up the same location?
Yes.
So
they'll all go to the worker roles instances will all go to the same queue, and so they'll just say get message, and whatever message is visible in front of the queue they will get, and then the message becomes invisible to all other workers. Then if it can process it, then if everything goes well, they can delete it. If things don't go well and say they crash, then the message will become visible again, and someone else will get it. That gives you the least one's delivery. But so basically it's a bunch of competing consumers. The worker role instances are all competing for the next message. One of them's going to get it, and then it'll just keep going through the queue. So you can scale out horizontally by just a bunch of worker role instances, just polling constantly. If the queue isn't sufficient capacity, you can have more than one queue. So you can sort of start sharding the queue, mess across different queues.
That's a very common pattern we see, by the way. A lot of the distributed systems out there, you have this queue with a bunch of background processes getting the next amount of work from the queue. So you don't have that worker process waiting to get data. It basically checks a queue to see if there's more work to do. And then if that queue grows too big, that might be how you scale. You might say, hey, that queue's got more than 100 entries. I better add more worker roles. And you can see here that the storage account is all tied in here. If I go to settings here, notice I have a data connection string here that I can relate to my storage account. So it's called Bruno Guestbook Storage. So I've gone into the portal, I've created a storage account called that, and I've referenced that storage account from my web role and my worker role. So that's how this project knows where the storage is. So that means if I go to Server Explorer, I should be able to go look into Guestbook Storage and find that rainbow. I've run this a few times, so let's go over here to Server Explorer, look at storage, and you can see here I have Bruno Guestbook Storage. And it's got tables, blobs, and queues. Well, we know that the blob is the one I just uploaded under Guestbook Pics. That's the name of the container. Double click. And you can see the URLs here. So we are at 4.9. This is the latest one. So if I go, I can go and grab the URL here and navigate to it. That's a different one. It's a thumbnail one, right? Let me maybe refresh this. So let's maybe grab this last one. So copy URL. There's your rainbow. So that's the blob that has the stuff I uploaded, both the thumbnail, right, because here's the thumbnail version that it's saved. It's a separate blob, right? That's what the background thread did. So if I go look now, see the thumbnail. Now what about the queues? Well, the queue's empty. Why is the queue empty? Yeah, it's already processed. The worker role read the work, dealt with it, and left. And it did go back to the Azure table, though, and add that information, I believe. So if I go look at that, we'll see that demo features here. Notice I've got the photo URL here, and I've got the thumbnail URL stored in the table. So the guestbook app is writing to blobs, queues, and tables. And it's using a web role and a worker role to do all its magic. Web role and worker role. So it's a great app in the sense that it shows you the web role, the worker role, and it shows you tables, blobs, and queues, all in one demo.
And to your point, Kelly, about scaling. So we talked about this today about auto-scaling, and so for you can use, for auto-scaling, it's typically driven off of CPU performance, as that's tracked. It can also be driven off queue size. It's one of the two performance things currently in the standard Windows Azure and for auto-scale. It's queue length and CPU performance.
So yeah, you can go and get the queue length. So if the queues started getting bigger and bigger over a certain period of time, you thought, well, I better go ahead and add more worker roles. Have many of you heard of the CQRS pattern in computer science? Command, query, responsibility, segregation. And basically it's this concept that there's these queues that you're reading from a background service. So I'm not going to get into that pattern, but it involves queues. And the idea is for asynchronous distributed systems, queue is your friend. Queue is your friend. All right, so let's wrap this PowerPoint off. We left off, I think we got it. A couple more things. We talked about the service bus. Any more questions about the service bus? This was that relay part I told you about. The Skype in a box. Breaks through firewalls. And if ideal scenarios exist, you get a direct peer-to-peer, which this doesn't show you. But in an ideal scenario, what would happen is this here would break down. This one right here would break down, and then we'd go like this. The store, I think I talked to a gentleman in the store here today. Do you want to tell me what you're selling in the store? Are you still here? So you can go and sell products here, add-ons. But that's different than a marketplace. Here they are add-ons. There's the portal picture of it. Then there's the marketplace, and that's where people sell data and services. So like Dow Jones, for example, puts their data out on the marketplace. All right, so I think we covered a lot of these particular topics here, the building blocks of Azure. There's more PowerPoints here. This is one of several. Questions before we wrap this chapter up? Open source, right? Windows Azure is open source, a lot of it. The SDKs. I don't know why you go in there and modify them, but they're there. So in this lab, we're not going to do it right this second, I'm going to ask around what you'd rather do in a moment, but let me just show you how it kind of gets built. So I'll say new project. Anyone have any suggestions where I'd go here for a cloud project? How about the cloud hive here? I'll call this thing guest book. The name might be taken. Let's see if it complains. I don't want a mobile service. I want a cloud service. It's there, so I can trick this thing. I'll just call it folder projects 2 here. We already tried that trick. What's going on here? 4. Wow, I did it a few times. So here's the part where I decide which web roles and worker roles I want to add to my project. Remember, the last one had 1 web role and 1 worker role. So let's go ahead and add the web role. And I'm going to modify the name to be more consistent. I'll just put guest book here. And now I'll add a worker role. I'll call this one guest book 2. Click OK. Now there's more than one kind of web role. There's traditional web forms, old school, or MVC. How about web API? What's that used for?
White-hat services.
RESTful services. It's the new WCF. Doesn't care about WS star standards though, or SOAP. We're going to do web forms in this case. So you're going to see 3 projects in total now. The first one's the configuration project. The second one is the web role project. And the third one is the worker role project with 1 solution.
I have a question there on the Facebook. Is it called the Facebook API?
Yes.
And what's the updatability through it? Because Facebook updates their API, so how the Microsoft keeps updating the Facebook API? If Facebook updates the API, how long is that take to update Microsoft?
Good question. Do you look at that, Neil?
No, but I suspect it's a lot. I mean, we don't update these things that often.
Well,
so I suspect it might be behind.
Sometimes it happens
Here.
quite often.
Here's what you do in that case. You go, how many of you have worked with NuGet? So NuGet's a way for you to add functionality. Let's see if Facebook is in here. So these things get updated frequently. So NuGet does what? It adds assemblies to your project and sets references and adds code from time to time. So it looks like this SDK will be updated frequently to me. So the NuGet package is a way for you to kind of leverage the latest SDK or library through this interface. So I would say to you very often,
If this is open source, you said something is an open source. So for example, if Facebook did the API and if it is open source, I just can download it from Git and then just update it myself. Is it possible to do? Or is it closed source, the Facebook API?
yeah, if you can go find their assemblies, get their compiled code or their source, I'm sure you can figure out a way that came into the project.
But you said something is like open source. So you
Yeah,
like,
sure, SDK.
so this one is not open source, like what's the Facebook part?
I would have to read what their licensing terms are on it. I don't know exactly. Does anyone know if Facebook is open source with their SDK?
Well, I mean, the Facebook gives you the information what they updated and you can write on your own, but this is like NuGet for the Visual Studio. And
right.
if this thing is open source, I mean, if like it's not up to date, I just edit myself and it's edit.
I think this is probably just the Facebook SDK kind of wrapped up with some NuGet. Anyone can kind of put NuGet package. So Microsoft's probably put a Facebook SDK for NuGet out there.
Well, I mean, I agree that anyone can, but for example, when you just need to change one word in the file, it's easier than like to create on your own, which sometimes requires much more knowledge. But that thing is not open source, right?
I haven't looked at
It's Apache 2.0 license.
So I don't know if the Facebook SDK itself is so. All of the Azure SDKs are GitHub basically, but I don't know if the source is available or make fixes that you have to.
It looks like it is on GitHub.
Pardon?
It looks like it is.
It's on GitHub, thank you. So my friend, it is on GitHub.
This is the.
A couple of years ago, we were using it. and they would just give you, the essentials.
Right.
Anything in the reference source and go to town.
But he probably wants the source of it so he can modify it.
2 years ago it wasn't available.
Yeah, but you see, it makes sense from the things like API is very, very like risky thing which might be out of date very quickly, and if like someone does not do the support or someone working on that project is late. It makes a lot of sense for like actual things which is has to be really open source.
Yeah.
Not everything has to be open source, but like,
But that's what Facebook issue is. I don't know if Facebook works.
Wrong crowd. Go talk to the Facebook.
Yeah.
By the
Microsoft
way,
stuff, Microsoft last week announced its .NET Foundation, so all of the .NET SDKs are running in the .NET Foundation. The Windows Azure SDKs and a bunch of XAML. The Windows Azure SDKs are all on GitHub, so you can look at the source of these. There actually will be patches that are available on GitHub, so you can sometimes get the most recent version before they're in the portal and download them from GitHub.
so this NuGet is compiled with Facebook and
Yeah, I have no idea how that Facebook.
Outer Curve is the name of the company apparently.
Are you asking what questions specific to NuGet or the library is contained
The Facebook,
inside
yeah.
the NuGet?
So I don't know how Facebook gets into NuGet.
yeah, that, I was asking about this NuGet which allows you to use the Facebook API, and then you send this like a packet from the library which you can achieve by
Yeah.
yourself.
Yes.
So the thing is that imagine someone does not do the support and you want to add.
Yeah.
So that's why the thing, like he was like having a slide where it was open source things, and like I was asking, is this thing open source where I can add something? But it looks like it's not, right?
Well, that's a Facebook issue.
So my understanding is, based on what that gentleman said, you could go to the GitHub repo, clone that repository, modify, compile it, and make your own GitHub. Make your own NuGet package.
Yeah, that's the problem in Google right now, is the fact that they allow you, they don't do any identification, and so you do end up with that where the original author, a project, right, will put something out there as a news package, but if you open sources it, somebody else can grab it, they can handle their own, put that up as their own media package. So what you end up seeing, it's kind of like news fan, you get like 15 different versions, and sometimes you can't publish one, you official one, you just tell them the reports that people have done, which cannot be a good thing, but,
This is a useful, this is a useful digression into this next topic of how would you add storage library functionality to your existing Visual Studio project, and the answer is NuGet right here. So if you wanted to, if you had an existing .NET app today on any platform, chances are there's a NuGet package, and you can add the API for the storage SDK right like this. So you wouldn't have to go and right mouse click, add reference, browse, and go find it. You just run that. And I'll do it again. It's already been run once, but you can see it run. It'll just simply, you'll probably say already installed. But it says, do you want me to go and add it to all my projects? Yes, I do. So it's doing all the appropriate DLLs and downloads and installs. So many of you probably already used NuGet in the past, I would imagine. This is not specific. This has been around 2-3 years now, right? So you accept. Now you still have to add the using statements to your code. But at least now the Azure Storage SDK is there. And by the way, after build, a lot of these are new and updated. Here's the service bus. You want to do service bus? Just run that. I love NuGet. It's kind of a DLL hell also. But certainly when you're in a hurry and you want a granular way to change your project, it's pretty awesome. Okay, so I have 3 pieces to my project. How come the other one had 4? Because it had a library, a shared library. So I go over here and I say add project, new project, and I'll type in class library here. And I'll add my, I could do portable, I guess, but not in this particular case. Class library, C#. I'll call it guest book.
What's the default trace listener with the service? You have a trace line in there? What's the default trace listener? Where do you get that trace line from? When it's a non-web role?
So there's a feature called Windows Azure Diagnostics. that it's an agent that gets installed, and you can turn it on. There's a bunch of modules you can turn on in the configuration, the service definition, and one of them is the diagnostics. And others things like remote desktop and stuff, so they're basic, fairly core things. So pretty much everyone that runs stuff turns on diagnostics. I think it's on by default. The diagnostics agent, Windsor Diagnostics is two things. One is you can configure it to say, here's the things I want to capture. Like this set of perf counters, this set of event counters, and this set of logs. And also my custom logs. You can say point a file, point a directory and say I want these guys captured. So you can point a list of things you're capturing. And then secondly, you can configure a persistence frequency. You can say every hour persist my IaaS logs to drop storage.
Here it is.
Where's our diagnostics? Either, yeah, this is a file. So you can either sort of entity-driven things like record things are persistent in table storage, like a set of different tables and table storage, like well-known, with specific names of table storage. And then like files are persistent in blob storage, again under kind of specific containers and blob storage. And so you can configure the storage account you're persisting stuff into, which should be different from the one you're using for production, because there is a performance impact to doing it. So the trace is either web role or worker roles is captured into a table and table storage, and you can then go and read it and query it and download it, etc. You can also do more sophisticated things like semantic logging. Microsoft patches and practices a number of things for Azure, including a semantic logging capability that's more sophisticated than just a simple trace. You can basically log objects, and it will keep the structure of the object through to the log. So you can do kind of, it's much easier to query if kind of everything's the same format, rather than just sort of someone writing a trace statement that's got random text in it. You can formalize the text with semantic logging. We also have a retry logic module that allows you to do things like retries automatically for using SQL database or table storage, etc. So Windows Azure Diagnostics is pretty important in PaaS services. And that's what tracing the systems diagnostics or trace is tied in with the Windows Azure Diagnostics. And you can just configure saying copied every 10 minutes or whatever, or every hour, send the traces over to storage. And the performance monitor, the performance counters, they're the ones that we fed into storage, and then the auto scaling is driven off them. And then you can see them in the portal. The portal's got kind of, it's got some like graphs of performance, and it takes the performance monitor counters. So you can add your own, or you can use existing ones, and then display the results in the portal with the service. So you get to see how you get a visual view of the service. And looking at the performance monitor counters that you configure through this file here. So this is just an example. It's mostly, so you look at the top, it's got a couple of directories that are configured. So IaaS log is going to be moved over to this WAD IaaS logs file. Crash dumps are going to get done. Logs are the trace logs. Then Windows event log is sent across. So you can provide a time frame as well, and then a whole bunch of performance counters. So you can modify that list in either code or in a file. This is kind of coming from a file that's deployed with your package. And then you can modify it afterwards. The API is kind of unusual in that the configuration is actually stored in blob storage. It's one config file for every instance running. And there's an API that will modify that config file. You could do it yourself, but the API just goes and modifies the file. So that's where the trace ends up.
All right, awesome. Good questions. We were just about to add a class library called guestbook data. Why do we put this as a separate project? Why add a fourth project here and make it separate? Yeah, we're going to share the data structures in there, exactly. So the tables, blobs, and queues should be done in a shared library. Because after all, web roles and worker roles are going to share that data. So this is the basic premise. And in the lab, you're doing just what I showed you. File a new project, add a web role, worker role, then you add a class library, then you run the NuGet package to say it to use the SDK. Once you do that, you're ready to start coding things up. And if you look at the finished solution, which is provided to you. Where's that guy hiding? Is this the finished one? Yeah. Sync that one back in. So if you look at this solution, all the data code now is living over here in this guestbook data. So if I look up the word queue somewhere in here, if I go look for queue, you'll see that here's my cloud storage queue. Here's all the kind of, let me increase the font a little bit. Here's all the stuff for writing the blob storage, queue storage. Nice and easy. Remember for the actual table, I just need to inherit from table entity. And then I can start saying new guestbook entries. So in the lab, that's what you're basically coding up. You're coding up all this stuff with storage accounts. Any questions about that? So if we look, for example, queue storage, I say find all references. You'll see here that it's very straightforward. I get myself a handle to the queue. I create the queue if it doesn't exist. I call the queue guest thumbs. I then create my blob storage, and I call the container guestbook pictures because blobs need a container. Create if it doesn't exist. Get permissions on my blob container, and you know what? Let's do something crazy like make them public. So now everyone can go to that container and get the blobs. Obviously, I could protect them. And so for the storage account, you can see here, get the queue reference. Where do we actually write to the queue? Let's go find that piece there. Queue storage, get reference. Here it is. Here's how you add a message into the queue. Get a reference to the queue we created, make a new queue message, and add the queue message to the queue. Done. How do we add an entity to the table? Well, create a guestbook entry, and then add it to the table. Blob. How do you upload a blob? Well, get your blob storage account and do upload from stream. Right? If I put a breakpoint here, you'll be able to see it all. Let's go ahead and see if this will run, and we'll maybe look at the breakpoint so you can see how this thing actually does its job. Then in the worker role, remember what that thing is doing? Do you remember? It's going to make a thumbnail. So it's got this run method, which loops indefinitely right here, and it's saying, hey, is there a message in the queue? If so, let's break apart this message, and then I'll put a breakpoint here so you'll see it actually get hit. Are we running yet?
You can see the worker role is a pretty basic service. It's really just starts up this like an init message allowing you to do initialization, or start method allowing you to do initialization, and then it's just a run. And if that run ever returns, the thing will just recycle. It will restart the server. So you basically don't want that run ever to end. So it's a very primitive way to sort of create a service.
Do you have to worry about air handling in any way in these calls?
For which calls? The start
Like just
run?
well, not those, but just like the kind of your call to your queue. Or
Yeah,
your
and then,
block.
so it's actually vitally important you handle errors. And, so tracing is part of that. That you've got to handle. You should handle it so the service doesn't crash, and then log everything. So like I went to this CAT training last week, and they said, for example, that every time you call out of your VM into some other service, you should do a significant amount of logging. Like how long did it take? How many times did you try? Like if you have to try more than once, say the other service is down, like do you keep trying or not? You don't want to get this thing where you just keep trying the service is dead. So every time you leave the VM, you should do extensive error handling and logging. Like log
So this kind of worker role is doing that, right, when it's accessing the queue?
Yeah, so the worker role is accessing the queue, and the queue service may be down. So you should actually, like, how long do these calls?
So what would happen there if you had the queue delete message and that
So-
service was down? So you could just
So the queue's down and you can't get a message. So you should handle the code of this, maybe retry a few times to decide, well, if I'm not getting any response at all, I know it's down. If there's some other problem, you'll get some error message. We'll respond with some kind of response, like it could be a 500, which is not good, or 403 or whatever. So look at if there is a response, you can decide how I'm going to handle that. And so the storage client itself does act like retry capability built in. You can configure like exponential decay, exponential retries, like 3 or 4 retries. Or there's the patterns and practices team has its own more sophisticated error handling system that will run against SQL database and all of the storage things. Or you can use it for your own stuff. So you can open source, you can look at and use that code. So anytime you're leaving the box, realistically you should be doing logging and error handling. Error handling and logging. So you can understand what's happening. Because the system, maybe the system's throttling is the far side. Like if you go to a third-party service, they might be throttling because you're using it too much. How do you handle that? So there's a lot of fairly standard, I think at this point, pretty well understood ways to handle that. There's like books written on this. I think it's a book releases, kind of like multiple chapters of how do you handle these large-scale services and the bits of breaking. So you might just, instead of trying all the time, you might try once a minute to see is it up yet. Instead of setting every piece of traffic and having it fail, just throw it yourself. Because then this is sort of a number of things you want to do with cloud services. The servers are more likely to fail than traditional servers, just because they're low cost. People realize that's the way to build distributed systems, is to make them horizontally scalable with lower cost servers, more cost effective than expensive high-end servers. There's an example I give to people. So late 90s, when eBay was kind of first coming up and the whole .com boom was happening, eBay was offline for something like 19 hours, like completely dead in the water. And the share price fell like 30% in one day. Because this is when the whole thing was bubbling. And so it turned out the whole of eBay was run on one Oracle database. And Oracle had guaranteed them this would not fail. It was like a never failed, and you could hot swap everything. And Sun installed a new disk drive and it failed. It brought the whole company down. So people realize it's much better to scale out, where the impact of a single failure is not so significant. If you've got 100 VMs running your website and one of them dies, the website's still going to be running and no one's going to notice. But if you've got everything in 100 core VM, it's not good. So it is crucially important we do handle failures and kind of assume they are going to happen. And try and turn that into an advantage, like horizontal scaling is a way to handle the failures of a individual server. But there's huge benefits of horizontal scaling. Your service stays more alert. So a big word is resilience. You're trying to make your service resilient. Another thing is graceful degradation. So when there is a degradation of some service, how can you handle that gracefully? So a lot of websites, you might notice occasionally some feature might disappear temporarily, because maybe that service is down, and they just want to make sure it's there. Rather than blowing the whole website up, they'll just pretend it's not there, and temporalize it on, and come back in there. So that's sort of graceful degradation. So think of things like resilience and graceful degradation as a way to manage your service. You try and hide these failures and you just pretend they didn't happen, even though you know they happen. Rather, if you bring the whole service down, it's not good for anything. So logging is good, retries is good.
There's also companies like AppDynamics here in San Francisco. They do very extensive monitoring and health diagnostics for your apps. They claim that there's like well, I've seen it, I've written an article on this, that you can actually visualize all your tiers and you can see like little bottlenecks where they appear. You can drill in and see exactly which line of code is slow. So if you're serious about profiling and monitoring and all that, you should take a look at third-party providers like AppDynamics.
Another one's New Relic. So San Francisco got two competing high-end application performance monitoring companies.
They actually, but these sponsor the Azure Bay meetup, so.
New Relic also works with websites. They've got an 8.1 with Azure website, so that's their claim to fame.
I said, we're ready to watch this thing. You know what's going to happen when I click go? It's going to upload the image. It's going to write to Azure Tables. It's going to put a message in the queue. The worker process is going to read the queue and make a thumbnail out of it, and then write back to the table. Of course you remember that. So let's go. All right, so here we are. I'm going to get rid of this window here to give us some room. So there's the actual content. So inspect, quick watch. So you can see there's the file we're about to upload. Where is it hiding? Does it give me the name? Well, this is where the content is. And you can see I've already got my, let me close this one up a little bit, shrink down a little bit. So notice we are got our unique name, just make up a name for it using a new GUID. Here we go, let's upload. So that just hit my storage account, that file. Now we're going to grab all that stuff I put in, like another photo. The message was a test, right? You saw that on the GUI, didn't you? We go back to the GUI, another photo test. So we're just about to add this entity to the table. There's your entity. Another photo, a test, photo URL, and thumbnail. Although we haven't created the thumbnail yet. The URL is there, but it hasn't physically been made yet because that's the worker role. So here we are. We're going to go now add that entity to the table. Done. And now we're going to add the message in the queue. And it's simply going to go and add the unique name, the partition key to the message. So this one big message has now been created. Let's go look at this big message. It's got a bunch of different pieces to it. You can see it here. Let's go over here. There it is. There's the message in the queue, which is basically the path. We're bringing in more food? Awesome. Let's add the message to the queue. And now I'm going to hit F5, which means continue. Hey, where are we now? What does it say over here? The worker role picked up the message. Let's go split that message, that comma separated message out. And we've got our string thumbnail here. And now let's go and make a thumbnail out of it. So all this code is not that interesting. It's making a thumbnail. I've done this a million times in other projects. Make a thumbnail. Now here's the key. Delete the message from the queue. Because we read it and processed it successfully. Should there be try, throw, catch, and more careful? Yes. It's kind of sloppy the way they did it, but it's a demo. There was no logic here, just, hey, message happened, error happened. So delete from the queue, go back, and that's it. There's not going to be any more messages here, right? It already deleted it, so when it gets here, it's null. And back out of here, and just keep looping now indefinitely in that separate VM.
So yeah.
What is your two worker role when you get to different things with that message?
So what you would do probably is either have two queues or two messages. It's probably the way to deal with that. Or have a queue with different message content. So the first one processed and did something else. So if you remember, I said everything should be idempotent. So if you've got like a workflow you're going to do, you should probably you can either do different messages or update the content of the existing message, which is kind of more or less the same. So you can handle it that way. So probably the easiest thing is to have two queues, one for each kind of task in the workflow, which is kind of what you're talking about. Is you need to do something. You need to do two different tasks. So you've got a workflow with two tasks in it, basically. So two messages is easy. Or you can update an existing message, but it's quite more simple than just have two queues or two messages. The first one completes the next one. So there's ways to kind of do that composition. So one thing Bruno just showed you there was that was all running in this local box. That was not running in any Azure data center. So this SDK and tooling comes with Visual Studio tooling. It also comes with a compute emulator that runs locally and a storage emulator that runs locally. So everything Bruno just showed you was actually running in a local box without any contact with the cloud whatsoever. You don't need a Windows Azure subscription for that. It's completely local to the service. You could then have done things like pointed the storage to the cloud and run locally for the compute, but the storage is in the cloud. And so that's a good, if you're doing some of that, it's a good check to make sure that everything's right. You can develop, just initially develop locally, use the local emulator, point the stores to cloud to make sure that everything's working right. Because it's not completely faithful between the storage emulator and the cloud. There's some edge cases don't work correctly in the storage emulator. So it's always good to test the storage out there with compute locally. But another thing you can do now is you can do remote debugging. Even once you start deploying to the cloud, you can play deploy to the cloud. You could publish this copy to the cloud if you wanted.
Yeah, how do we do that, everybody? Do you remember how we would publish this to the cloud? Thank you, menu. So right mouse click, publish. Let me go back to the beginning of the publish. So, what's the service, what's the cloud service? New service Bruno. That means if I go back to the portal, I imagine I have a new service. So go to cloud services, right? Cloud services, new service, Bruno. I could create a new one here if I want, for the fun of it. I could say, quick create, SF service. It's available. Create it. How long are services taking these days? They're like instant, right? So our service is up. It's right here. So let's go back to Visual Studio and tell it, maybe I need to go back to refresh this thing. New service, what did I call SF service? Still not showing up. Let me right mouse click again. Right mouse click, publish. Go back.
There. Second bottom.
Second bottom. Where are we at?
Oh,
duh, right there. Thank you. I'm tired, everybody. So, SF service. There it is. I'm going to publish to that guy.
So you can see it's got an environment production. So a cloud service has got two slots for PaaS. It's got a production slot and a staging slot. And the idea is that the production slot gets the full DNS, like sfservice.cloudapp.net, and the staging slot gets a fluid.cloudapp.net. The idea with staging slot is it's kind of like a blue-green deployment, so you can kind of deploy to the staging slot, do some quick tests, smoke tests, make sure everything's right, and then do what's called a VIP swap, and then move what was in staging into production and what was in production to staging. And the VIP swap literally just swaps the DNS entries are in the load balancer, so it's almost instantaneous, and you can swap your staging into production. So Bruno's doing a deployment directly into production. This is brave. And,
photo upload app is right there. Yep. Easy
set it up.
What's taking so long?
It takes a few minutes to do the upload. What it does is it uploads. The publish makes two files out of your solution: a package containing assemblies and the config file, which is a pretty small XML name value pairs, and then uploads the two to a secret store in Azure. Then cracks them up. Once the upload takes depends how big the thing is, it might take about 5 minutes. Then once it's done that, Azure cracks open the package, looks inside it, works out the service topology, how many instances of a web role, how many instances of a working role, how big they are. Then it immediately starts deploying all the instances of UCAN. I think Bruno's played it like one instance of a web role, one instance of a working role. They're all small, so it just finds that one core available in two different places, spins them up. Then it installs the web role code and the web role, installs the worker role code and the worker role, hooks the load balancer up, and then it'll all be going. But I bet he didn't change his storage account for the queues.
Is it still on local? I think we're okay.
So it's a common mistake is when you do the publish. There's like the local configuration and the cloud configuration. The local one's hooked into the local storage, the cloud one should be hooked into the cloud storage. You've got to remember to configure the cloud storage before you do the upload.
So you can see it's connecting, it's uploading, creating. And what he's talking about is over here, like if I go to my settings, I need to be careful that I don't choose local storage emulator that I want to use my real storage account, right? Because I can use the emulator, so you can fake tables, blobs, and queues. When you install Visual Studio, it insists to have SQL Server Express because that's where it puts all the stuff. In fact, I think I have SQL Server. You can see the fake tables, blobs, and queues in the database. Let me see if I can find it. Databases. Let's see it on this one here. Paragraphs, my local files, covering. So it's using the database. I might have SQL Express in here. So my point is simple. But before you deploy, make sure you set these settings to the proper endpoints. I don't want to use the, if I wanted to use the emulator, I'd just go over here and choose use local storage emulator, and then you'd see use development is true over here, as opposed to the real endpoint that I want, which in this case is what? Who is it? It's a, let me look. Bruno guest book storage. So I should go set it back. Go back to my subscription, manually entered, guest book storage, and there's the key. Hey Bruno, someone got a copy of my key. What am I going to do now? They can get into my storage. Well, not so true. You can go back to the storage account, go back to storage and go bring Bruno guestbook storage, and you can actually redo the storage, regenerate the storage keys. So this is really what it's copying into Visual Studio. These special access keys to storage. You don't want to be giving these things away and passing them across the wire. These should just stay within Visual Studio.
What's the difference between primary and secondary?
Yeah, it's for key rollover. So say if you're using primary in production, and you decide it's the end of the month when you want to get a new one, you can just stick the secondary in and then regenerate the primary. So there's no difference whatsoever between them. They're equally usable.
No downtime.
So it's just purely for rotations. There's always one valid one at any time. If you only have one, then when you're regenerating it, there's a time limit. You don't have any valid storage. So you have to. There's no difference other than that.
Can you talk about certificates in the services?
So
Services to certificates?
So there's two types of certificates used with Azure. One is management certificates, which are used for authentication for a bunch of the APIs. The management API uses certificates. And they're just self-signed certificates you upload. You have on your box, you can upload them to Azure, and they can use that to verify who you are. The other one is SSL certificates, if you've got HTTPS. So what you would do is in the service definition file, so there's two configuration files. One is service definition, one is service configuration. And they're usually very, very strict configuration and definition. And so things like params should be defined in the definition and configured dynamically in the config. So what you do in the definition file, you will say for this web role, I'm going to use, I'm going to have a certificate. And then the configuration file, you provide a thumbprint for it. The idea being you can always change the configuration file afterwards and not only upload that, not the whole package. So you just tell the web role, I'm going to use this certificate. The config file knows what the thumbprint is, and then you add it to the portal. You just go to the portal and say, here's my certificate. And you go to the service and say upload SSL certificate for this service, and it will automatically deploy it to all the instances of the service. So you don't have to log into any of the machines. You just say, in the configuration, you say, here's the thumbprint, here's the certificate, here's the thumbprint for the certificate. On the portal, you say, here's the physical certificate, and the portal will handle all the distribution. And then if you want to update it a year later, you just do the same. You just modify the configuration to provide the new thumbprint, stick the new certificate into the service in the portal. So as I said, the thing to watch is there's two different certificates on the portal. One is the management, which is just purely for your authentication to the portal, and the other is a standard SSL. So the management is self-signed. You can create whatever you want. You can buy whatever you want, but you can just self-sign it, which is what most people would do. And the SSL is just a regular SSL certificate. So Azure handles all the distribution to the machines. If the machines come and go, it'll distribute them automatically. But you do have to say in the configuration what the thumbprint is. and put the fact you're going to do in the definition.
So here's some PowerShell. I've got PowerShell IDE up, and part of what you need to do to get PowerShell to talk to your portal is set up these certificates. So part of your job is to download a certificate to PowerShell and then set it up. So now, here's all the stuff here. Look at all the different PowerShell. This is not really a part of this particular class typically, but you should know there's a bunch of, PowerShell scripts here. For example, add VM, add virtual disk drive, add DVD.
Anything you do in the portal, you can do it using PowerShell. And some things you can't do in the portal.
Put your get, Azure disk, get Azure. And what's kind of nice about this, I could say get SQL database, and then I give it the context, and then say insert it. So it'll fill out the command for you. Azure storage container. That doesn't look like it has any required parameters, so I can just run it. VHDS. So anyway, these are all the stuff you could possibly imagine is here. It's all here. Are we deployed? We're going to take our little afternoon break here in a second. We are deployed, and notice there's the URL. Restart Windows, nonsense. So here's guestbook. Got to warm up the URL. Okay, how come when I ran it on my machine, I uploaded those photos, and now when I'm in production, I see the photos too? How could that be? After deployment, why is that? You know?
You had the wrong checkbox check.
Maybe they pointing to local URL.
They're pointing to the same storage account. Whether I run my account in the local emulator or deployed, they both pointed the storage to the production storage account. When I ran it locally, I still pointed to my storage account. So yeah, it's a checkbox. I couldn't go back. If I want to talk to my local system here, what do? Do you remember? We go back to Azure here, and we go here and we set the settings to local. We set it to here. So you can run your project locally, but be talking to cloud-based storage. And you can deploy to the cloud and also, of course, talk to storage. But you can't deploy to the cloud and then talk to your emulator storage. That doesn't make sense.
Same goes for SQL databases too?
Yes, you can't, unless you set up a VPN, you can't necessarily. That's a good question. Can you hit port 1433 from the cloud back to on-premise?
If you're gutsy, you could do it. So if you're running again, so one way you're doing development, you can actually just point to a local SQL server if you want, and because most of the stuff is the same, and then just kind of then point to the cloud one. Can do the trick as I explained earlier. So start with do everything local, then point the storage to the cloud so you can get the keys right and stuff, and you know it's working, and then move the computer up. It's kind of one way to do it. It's not so important nowadays with the tooling, but the old tooling, like up to about 2 years ago, there was one config file, and people kept forgetting to switch the keys around. Now they actually have 2 config files in Visual Studio. They have a cloud and a local. So it's a lot easier to get it right because you can just do it. But I think Bruno just did one config file, and you can see the issue that he probably meant to do the local one locally, not remotely. So it's just a thing to be aware of that you go to the right place. But SQL servers are it's a totally fine way to do local testing or web surfing and use a SQL database. Because most of it's going to work. You've just got to be careful about latency. One of the issues that we run into is people do stuff locally, and there's very, very chatty applications, and you want to avoid chatty applications. I worked with one person, and they had done something local. Some developer did all the stuff in one box, website and SQL Server. And it turned out the home page of his website, it was like an e-commerce website, and the move to the cloud took 29 seconds to come up. And that was the home page. part of the first problem was that the website was here in Chicago and the database was in San Antonio, so we fixed that one. The second problem was there was 1,200 store procedure calls to the whole page. Part of it was they were trying to do a here's what people liked, similar to what you're looking at, and that took, I think that took a total of 300 store procedure calls because they queried for everything separately. And then there was a bug and everything was done twice. So in the cloud, it's important, especially when you're going across systems, to try and avoid overly chatty interfaces, do chunky interfaces, like do with store procedures, trying to get as much data back as possible and push as much data in as possible. So do things like table value parameters and stuff instead of just individual record at a time. Because every time you leave the box, there's a latency, there's a chance that things go wrong. So try and do sort of bigger chunks at once, especially with SQL database.
Oh, that's typical optimization.
Well, a lot of people say it works fine locally because you're on a box and you've got a high performance SQL server. But when you go to SQL database, the performance is much lower. People are surprised. You don't want to do too many calls, unnecessary calls.
So, good. Thanks for all the questions. Does anyone have any? I was thinking we could take a little brief breather. Now, what's the feeling on the content? Do you want to have time for work in the guestbook lab, or do you want to take your break and keep lecturing, finish at 4:30-ish, 4-ish? Anyone need votes? Keep going? Keep going, more lecture? All right, so you do have 20 minutes now where you can at least go and look at this lab, make sure that you can at least read the lab. If you can see the lab gets into, let's just review in 2 seconds. So we have a web role, which you saw, that's running IaaS. The only difference between a worker role and the web role is one's running IaaS. The other kind of key learning I want you to know is that tables, blobs, and queues are part of this latest exercise. Blobs live in containers that can be given public permission. I think the kind of architecture here was important for you to understand that the queue is a mechanism by which web roles and worker roles communicate for work to do. I think this slide says it all about a decoupled distributed architecture. And then just walk through this, see if it makes sense. It's what we want. We really walk you through every single. Look how small this thing is, though. It's a lot of work. How long do they think it'll take? This is kind of amusing, actually. How long? 2 hours? 8 minutes? 120 minutes. But we're going to start at 3:10, so please take a break, and we'll resume back with the last section of the day. Yeah, I know. You guys are going to fall asleep on that.
So why don't you role?
Yeah,
usually applies to security. Basically
Yeah, I agree. Think of it as, just think of it as a process running in a VM. The web role has IaaS in that process.
So role is security of it. It also does cyberspace, or it's just a process?
Just a process in a VM.
And they all run under what
That's
well,
all-
actually what privileges?
Well, you don't have full privilege. You can remote in, but there's very little you can do because we don't want you messing around with VMs per se. So there's really not, you can't get in as administrator.
Okay, so the role is probably used here.
Yes. Yeah, and in fact, there's a notion of a VM role, which used to be a virtual machine. We called it VM role. But we got rid of that because it was stateless. If you reboot, you lost what's on the VM. Now they brought back virtual machines, And now VM role is being used for a different reason. It's used as a template definition for a virtual machine that you want to build. So they've taken a word, made it obsolete, and brought it back with a new meaning because all the good names have been taken. And there's patents, and it's very difficult to come up with names. Yeah, you'd be surprised how difficult it is to come up with good names. But if you have some good ones, mail them to me. I'll tell you the people.
So you're not a liability, you're not a cost center, you're an actual asset.
Right?
Actual investment, engineers, certified, subject matter expert, clients.
Yeah, right here. Well, you want to look at the hypervisor, you're taking snapshots and all that.
Would it create like the internal SIDs and everything?
There's a process for that, yeah, you can do that. So if you look over here,
I actually just started
you look at like virtual machines,
trying to turn the business model around a
it
little
allows
bit.
you to take a snapshot. And then you can even take an on-premise one, SysPrep.
Yeah, that's what I said earlier when we were artificial intelligence system.
Yeah, you can do the same thing
And then
here.
you would add those
Three different times in the years, started out as a
Yeah.
DOS app.
whole thing and still.
That's
So
right.
two clients that are running a DOS app.
Check into that, yeah.
We don't talk to them. Well, their last incarnation was about 2 years ago. It's sort of live.
Yeah, let's see what you got.
And then there's a link forms policy. It's like insurance management software. But obviously Silverlight is going away with Azure. So, yeah, so that's where we're at right now. It's basically building out a multi-tenant SaaS system as opposed to the current on-premise model. Like throw it up on Azure. We're partnering now, so try to get our competition on top of it. So it's kind of like in a way trying to bring back kind of like some startup-ish type, feel to some of the new product development stuff. But at the same time, it has been around for a while, so it's extremely stable, it's profitable. There's no issue there. I agree. New product, basically doing all this stuff. Building from the ground up. Interested? Especially like trying to find people who come to these kind of events, it shows that you're actually interested in, learning. Yeah, getting involved in these kind of things,
That's the problem.
Gut? Gut? You don't complicate it. Ui, I forget.
That'll work. Let's put the S in there though. How about just Azure 214? That's taken two? We'll spend here a few hours, don't worry. Azure. How about Bruno Azure? That's free. Share it. No, I don't want to share it there. I think it should work. Bentley, Bruno Azure. Go to PowerPoint, put that up here in case you were not seeing that. HTTP bit.ly. Some people type in bit.ly.com, but it's bit.ly, Bruno Azure. Is that working for you?
Yeah, I got it.
Good. All right. So PowerPoints are up in Azure Storage. You learn another lesson. Who needs Dropbox?
I have a question. So I use cloud storage for the same purpose as I use Amazon S3. I mean, Microsoft storage for the same purpose as Amazon S3.
Yes. I believe so. Yeah, those are like blobs, right?
So you can like set up like expiration headers or auto-gzip or all that stuff, right?
Yeah, you can put metadata onto the blobs. Two different things. And so you can just think like shared access signatures as well, and take the time. If so, pardon? Oh. Oh. So you can have stuff that's private and the shared access signature to give time limited access to the things. Or you can fully private or fully public or intermediate or this kind of time limited.
Oh my God.
So you use a query string, URL with query string, the last like an hour of text.
And is there any
29 clicks.
any bandwidth protection or like for like bandwidth seekers or like
For bandwidth?
yeah, for example, if someone decides to upload an image 2 million times,
No.
nothing on that end?
You just run it. There is a maximum bandwidth of it allowed. There's like 60 megabytes.
Is it a fast download?
Nope.
Because of our
Like 0
network.
kilobytes so far.
It's our network, I'm sure, here. But it'll be up tonight, so just please write it down so you don't forget. It will be, yeah. I'm always complaining, on your evals, complain about the network.
And it's charged you monthly by the amount, right?
It's charged, yes, charged by the amount. It's billed monthly, but it's charged by the amount.
I'll put it on a thumb drive, too.
I can't remember, 12 cents a gigabit. 12 cents a gigabit. Something like that. Maybe the first gigabit's free. There's a pricing page for when this is
Okay, but there's no such kind of limitation like all on 190 or 190 or like some kind of.
No, it's none of that kind of stuff.
I'll give it to you. Copy. It's zipped. That should work. Save to
Is there any other questions with storage? Or anything you've heard so far today from Bruno's dealing with this?
What about the other support, like PHP and like when you use MySQL, is it limited or something possible?
So with the websites, there's actually one of the options with websites is you can point to SQL database files that are hosted by SQL. ClearDB does.
Okay, Christine's gonna put this on the drive, so don't worry about downloading. Here's another one.
And then the API is changing as in Amazon, like for example, we cannot set up the web address because in Amazon the API address is changing.
So the way Windows Server is for cloud services, PaaS or IaaS. As long as you have something deployed, the IP address changes. If you have nothing deployed, you will lose the IP address.
What if I restart the?
So if you do the shutdown, we taught you have one VM running, shut it down, bring it back up, you'll probably get a new IP address.
Let's get started.
So you have to have something physically deployed for the IP address to be set. The outbound IP address will be the same as the inbound one.
And not just to get the fix that you want somehow.
You can't reserve, there's no, you can't reserve it. That's, websites, I think the address can change, so you have to be careful how address changing. I haven't seen any documentation saying could change, but I've heard people saying it does change for websites, not for roles.
Yes.
The 2 zip files in your thumb drive or the one that or the PowerPoint? Okay.
What's it called, Christine?
It's
I should definitely.
PPT, yeah, that's the one you want.
Any other questions?
Yes, let's do the next. Can we do the next module, please? You guys ready? All right, so Active Directory. So this one has been, there's like a longer, more involved one. Let me go back to my blog. So the old lab, before I got it, was working with Visual Studio 2012. And it was somewhat dated. I mean, things date like in a week. As soon as build comes around, things are dated. But we've been working really hard, my partner and I, to kind of get this up to date. So if we look at this one, this is the one we're about to do with Visual Studio 2013. But I have an older one that goes into 2012, and it goes one step farther than this one does. In other words, it manipulates the Graph API in Active Directory. So do you know what the Graph API is all about? Being able to go figure out attributes about users in Active Directory, being able to navigate what groups they belong to, and so on. So we chose not to, so you can blend the two. So let's go and address this particular section. So AD.
Are you going to be covering Graph?
Yes, I can show you. I can show you through the blog post. It's pretty much similar.
So I implemented it. We had a couple of different questions.
Sure. Now AD is a big space and it's a fast-moving space. So there's the Winity Identity Foundation toolkit. Has anyone played with that here? So this is a whole training kit devoted to identity. And I'm wondering how up to date it is. So why don't we do a quick, it's not up to date. Windows.
I think it's 2012. So I think they're moving on. So Windows Identity Foundation's been out for about 3 or 4 years. I think the plan is to move on from that. The API is getting simpler. We're moving away from Windows Identity Foundation.
Okay, so the guy that's the leader on this is Vittorio. I wish he'd been here on build. He came here to talk. Vittorio Bertacchi. So he owns identity. This guy here with the long hair. He owns identity. So if you ask me difficult questions, I'm probably going to say, hey, let me go ask Vittorio. Because he spends his whole life immersed in just this space. So if you need let me throw out some names here so you know who to maybe think about. So Vittorio owns the developer experience with Active Directory in the cloud. This guy, Brad Calder, he pretty much invented the storage system, Brad Calder. So he pretty much is a very well-known guy at Microsoft. He's a technical fellow. Azure storage. So Brad Calder is the guy in storage. This is him here. Okay, and then Basters Clemens is for Service Bus. So those are 3 names you should maybe take into account. Vittorio Bertacchi, Clemens Basters, and Brad Calder. Those are the guys that are kind of leading up those technologies. So when I read my article, these are the guys I talked to get kind of some hints.
What was the name of the
He's great to listen to because he speaks like this.
It's sharp on Channel 9.
I'm sorry?
Sounds a lot like the guy who did the F sharp on Channel 9.
Oh, yeah, he's got the...
That's where his name. It was great to listen to.
Yeah, just for the heck of it, I don't even care what he's saying.
Victoria, a place like Bill, he's a really important speaker. He'll do hand drawing. Entire presentation hand drawing. He's really into this. So he's got a nice blog. You guys should be looking at his blog if you haven't already. Look at it.
So if you're an identity guy, this is the place to look. He knows stuff that's coming around the corner.
So one thing with identity is it's a rapidly moving field, and because identity is not just an individual company, it really requires industry standards. The standards are changing fairly rapidly, and different companies are trying to implement them. So that's why things like WIF might be big 2 years ago, but it's gone now because the standards set have moved on, and that's no longer good technology. So it is moving rapidly. I was talking to the Active Directory people yesterday, and they're saying that their group seems to be moving faster than almost any other group in Azure just now. Every 6 weeks, there's new stuff coming out.
Okay, so I'm going to bring you to the build website. because that's where all the latest, absolute latest sessions are right now on our technology. So if you're wondering, hey Bruno, where can I go right now to get the latest on everything? This is definitively the spot. Build 2014 just happened last week or so, down the street from here. And so if I go and look here for Vittorio, maybe we'll play a couple minutes of his video. No, we don't want that. We want it on, so I have to look in sessions here, I guess. Speakers. It's
Oh yeah, you got it. This is no?
There it is.
Okay.
So let's go find Vittorio.
Finish. Let me bring.
I build also, so this year's touring fellow, Leslie Lampert, who works at Microsoft Research and Learning Group. He did a talk on thinking like a programmer.
All right, so where's my, we're obviously not going to display his all his content, but at least enough for you to get a flavor of what you can expect if you go to this site, which I encourage you all to do here after today. Go watch his full hour thing if you're really curious about AD. I have to still watch this. People think, oh, you work at Microsoft, you drink from the secret fountain of knowledge. No, I don't. I got to go and watch these things just like you. Okay, I've got to turn my silly speakers on because I have my headset on. Control audio. I just want to hear his Italian accent. That's the only reason I'm doing this. So, enable. Okay. Grab the URL. Go back in. Speakers ought to work. Hope it's not too loud. Got to get my finger on the throttle here.
Buongiorno everybody and welcome. Thank you for taking the time to come here and spend 1 hour to talk about Azure Active Directory. Well, talk. Actually listening to the hippie talking about it. That would be me. My name is Vittorio Bertocci. I am a program manager in the Active Directory team, and my day job is to think about developer experience. And that's what I'm going to chat about today. I'm going to spend some time exploring with you the notion of taking advantage of Active Directory for securing your rich client applications, native clients, mobile clients, all that kind of stuff.
So I'm not sure if that meant web-based clients. So when you talk about native, you're talking about thick client apps. So that'd be a good complement for what I'm going to talk about, which is thin client.
Now, when you think about Active Directory, probably you don't think about hip stuff, Lady Gaga, or modern things. Active Directory is very much still in the collective imagery, the thing that was created in the late 90s. It was created in the late 90s for managing the resources of the time. And that was a different world, with different kind of resources, and we were all different. At least I was very different at the time, as you can tell. And I did have better pictures, but they were all with the ladies that I dated at the time. My wife claims that my videos are boring, so she never watches them. I could have used it, but just in case, just to be safe. Anyway, that was me in the late 90s, and that was my phone. In Italy, mobile phones were all the rage. It was really a status symbol. So in '98, I paid like a stupid amount of money for that D470. Guess how many apps run on that phone? One, the phone. You could use it as a phone. And Active Directory only cared about it to the extent of which I could put my number if somebody needed to reach me in this. So clearly, today,
come on, Victoria, let's get down to it.
Like if you take all of those resources on their own, they are disparate, they are different. Like Active Directory provided the lattice, the glue, the fabric, which allowed people to work with that. Administrators to administer those things, as the word says. Developers to manipulate
Okay, the best thing about Build is over here. You can go download this file and put it and extract the audio and play it in your car when you drive. There's also the slides are available here. So think about downloading these slides, which I'm about to do here. So I'm going to put that, say, in downloads, download Victorio. So I would say this slide deck is going to be better than the one you're going to get for the one I just uploaded, of course, because it's the latest, and things have been changing up at the last minute with AD. It didn't open it. Darn it, downloads. Sort by date. Victoria. Double clicking doesn't want to work. Fine, be that way. File, open, downloads. I have other ways to get in here. See, browse, downloads, Victoria. So he's got a 24 slide deck. I've never seen it, so I'm not going to try to talk to it. So he's talking about here iOS, Office 365 apps, Windows Store apps. How do you work with OAuth 2? OAuth 2 is quickly becoming the protocol of choice for this type of token format, right? Because there's lots of different tokens. So since I didn't, create his deck and I don't know about it, I'm going to go to our own deck right now. So leveraging popular social networks and so on is what we might talk about. Access for businesses and partners. So social networks, meaning how do I log in with Facebook, Twitter, and so on. Single sign-on is kind of what this next part is about. You have a federated scenario where you want this SAML token to travel from one company to the next. Maybe in a supply chain scenario, you don't want the person to continually log in. And by the way, this gentleman here told me about some IaaS setting. If you have two web-balanced web servers and you don't tweak this one setting in IaaS, they may ask you on your second visit to log in again because they went to the second IaaS server, not the first one. So if you get asked to log in twice, there's probably a setting in IaaS you need to make so that it doesn't ask you again, so that this cookie and the session state is all kind of shared among the two web servers. Okay, so do you remember this old world of, this is basically leveraging Facebook, Google, Yahoo, and so on. You've heard of WS Federation, kind of some standards out there, SAML tokens, HTTPS, and IIS. It's been around for a while. The notion of the SAML token from a browser. And then there's a world of SOAP, which is basically machine-to-machine computing. That has its own identity model in it. And you notice in the lower right all the WS star standards. What's happening to this view of the world? It's going away, right? SOAP is falling out of favor relative to REST-based approaches, because of the heavy payload of a SOAP envelope. So we get into this debate about REST versus SOAP. REST came out of a dissertation by Roy Fielding. Not really, it's kind of beside the point. So one of the takeaways you'll get from Vittorio's talk is the world is going to OAuth 2 as the kind of message format, the token format, OAuth 2. It's web friendly, it works in browsers. Delegated access means I can pass it along in a supply chain from company to company without having people log in. So the way it kind of works is I go to basically this, to a site, and essentially there's an authorization endpoint and a token endpoint. So this authorization endpoint is where I log in and provide the user interface. And then once I get logged in, I deal with a token endpoint, which gives me a token, a SAML token. And those yellow bars inside the token, they're called claims. Claims are attributes of the person who's logged in. So if you're at, for example, the Yahoo, it'll have an email claim. But if you go to Live ID, they don't give you an email. So basically, it's attributes of the person logged in. Now, if the identity provider is Facebook, it might have different attributes than if the identity provider is Yahoo. But at the end of the day, you end up with one token format. That's the main important goal, is that you, the developer, don't have to say, okay, if token type equals Facebook, then do it this way. Else if token type is Twitter, do it the other way. To you, it's just a SAML token. You can query the claims in the token with link queries. And then based on those attributes, you can make authorization decisions, right? Authentication means we know who you are. Authorization is, can you go to that secret page? And you do that by examining either the role or examining that person's attributes. So the secret page here eventually gets the token, and it validates who you are and lets you get to the content. So like I said, the user interface comes into play. You log in on the authorization endpoint. If things go as expected, you're going to get a token to come back. When you get this authorization code, back, you take the authorization code and then go to the token endpoint, and then you get your token at that point. Then the token gets submitted. Now, this is all transparent to you, the developer. Don't worry about this. You leverage Active Directory. This happens all behind the scenes. But you can, along the way, add things to the token, look at the token, standardize the token. And what's the format of the token, by the way? It starts with a J, ends in an N, and it's 4 letters. JSON format. So it's a web-based, traditional JavaScript can let you look inside the token. So this is OAuth 2. And then there's this whole concept of OpenID, which is kind of an industry standard. And so that's where everyone's headed. If you talk to Victorio, he'll talk to you about the difference between OAuth 2 and or OpenID. They're related to each other. I think I might have gotten that's good. So again, this is a situation of you're getting the token, and see this one we covered, REST, I'm not going to do that. I think what I'd like to do is walk you through this lab and maybe have you guys kind of look at that lab.
I'll put a few comments in.
Yeah, please do.
So a few years ago, Microsoft introduced the Access Control Service to Windows Azure. And it was what Bruno flashed by was an STS, a secure token service. And the idea is that it could essentially federate security with an on-premises Active Directory or another identity service like Ping Identity or something. So on the corporate side, it would be federation, and then it would also deal separately with social network providers like Google and Facebook and Yahoo. And it would provide a central location whereby you could configure what would happen to any inbound claims coming from these providers for your application. So your application would just see a single token for all of the different providers. The token would have a standardized set of claims. So for example, Windows Live / Microsoft account has got like username claims, but it does not have email. Whereas Facebook and Google would give you email as well. So the idea with this ACS, we kind of take the disparate claims coming from other providers, whether it's social or enterprise, and merge them all into a single claim type that your application would understand. So your application was completely isolated from the claims coming from the outside world. It didn't have to deal with Facebook or Yahoo, it didn't know about that. Then your application would deal with profiles for its own users. Because the profile information wouldn't come through the claims. Claims is just a small thing like this is an authenticated user with this name, they're in this role, etc. So those would be just a small number of claims per token. And then your application would separately deal with profiles. So that was the access control service. About a year ago, Microsoft introduced the Azure Active Directory service. And what that is, it's an identity provider. And it happens to be the identity provider behind Office 365. So if you're using Office 365, you're actually using Azure Active Directory. We basically took the directory service for Office 365, split it away from Office 365, and turned it into Azure Active Directory. Yep.
So that's like the login I use to log in my Windows 8, right? The same if I...
Your Windows 8 is called a Windows Live or Microsoft account. It's not an Oracle. So there's two different types of account Microsoft are looking at from their perspective. They have Microsoft accounts, which are the end user kind of Windows Live, Outlook.com, Live.com accounts. And then they have organizational accounts, which are enterprise accounts like Microsoft.com or Satori.com or Your.com or whatever, that are hosted in Office 365. So if you're using Office 365 corporate email, you'll have an Office 365 account. And that, the directory for Office 365 is Azure Active Directory. So Microsoft have now opened that directory up, and anyone can actually create a tenant. You can create an Azure Active Directory without having Office 365. You can go to the relevant website, you put in an Azure Active Directory. It's on the Azure portal actually, and without having Office 365. So the idea with this type of access is that any company can create an application that can become a tenant of Azure Active Directory. And especially for corporate-facing applications where you think you're going to get a lot of corporate users, you can work with the Active Directory team and get your app on the list. They have currently 1,200 applications that are kind of hooked into Azure Active Directory. It's just tenants, like single click. You can go to the relevant place in the portal and say, I want to use this application. Give me access to that application under single sign-on to my organizational account. So like, I actually created a fake organization last week to try this out. And so I had a Twitter as one which is free, but you can do things like Dropbox. If your company's got an agreement with Dropbox for an enterprise account with Dropbox for your employees, you can, from the Azure Active Directory portal, you can say, add Dropbox as a tenant of my directory. I will allow the following users access to Dropbox. The idea being there that when the user leaves the company, you cut them off just by regular AD stuff, and then they won't be able to use Dropbox from their corporate accounts. So it's a way of providing corporate control, corporate single sign-on to third-party applications. So from the perspective of this audience, you're more likely to be developing applications that may be corporate focused, and ideally you would end up and you sort of have the relevant discussion, you do the relevant stuff and have the relevant discussions to get your application into that portal to be one of the 1,200 on that list. So that then, the organizational guys inside an enterprise say, oh, I want to use that application, let's just give our users access to it. So there's the two different types of identity stuff going on in Azure. And the Azure Active Directory is kind of where all the focus is on right now. The ACS is going to be, traditional ACS is going to be deprecated at some point. And the feature set from that is moving slowly into Azure Active Directory. That's the part that's going on into the future. So you can have your application talking to Azure Active Directory, and if the person can single sign on, then you can start, if you've got the relevant permissions, you can then start looking at their social graph inside. The bits you're allowed to look at inside their profile connected from Azure Active Directory using the Graph API. So you can log in from like mobile and Windows 8 devices, etc. Organizational things. So there's a lot of focus with Azure Active Directory on organizational accounts. So focus on enterprise rather than social, to be honest. That's where all the action's been so far. But you get the benefit of it. So if you're letting people log into your application using Azure Active Directory, you get the benefit of sort of Microsoft doing all the work of getting rid of hackers and stuff like that, password resets, etc. Is there any questions on the distinction between this and all of it? Any question? So the directory used to be was just hidden inside Office 365, and Microsoft split it off and made it a completely separate product. So Office 365 is a tenant of the directory, just like your application could be a tenant of the directory. It doesn't have special privileges into the directory. Well, maybe it does, but in essence, it's best just to think of it as yet another application using the directory. It's not, the directory is not integrally weaved in. You can use the directory without using Office 365. So if you have an Azure account, you go to the Active Directory tab and set up a directory, and it's you never need to see Office 365. Yes, so, wait, this is not necessarily going to answer that, but it'll help to clarify something. So most of you have probably just set up a Windows Azure account if you're only using a Microsoft account like live.com or outlook.com. And then you can create a Active Directory in that. If you want to use for the full Office 365 person who wants to use Active Directory, who wants to see the Active Directory, you'd have to do it the other way around. You create the Office 365 first, and then create the Azure Active Directory, create an Azure subscription. Then as a company, you can start managing all of your Azure activities using corporate accounts rather than individual accounts. Because this is historically one of the problems when people do Azure. They just did a bunch of developers, each with their own Windows Live account, and they left the company. People forget to cut them off. So you can do Office 365 and then add an Azure subscription into it. And that's the way the administrator would see the Azure Active Directory in order to add the applications. So yeah, if you're an enterprise that already has Office 365 and you want to be able to add applications, you'd create an Azure subscription that you're only using for the purpose of seeing the directory, because the directory is exposed in the portal. And then in that directory, you can start adding the apps if you want to add the apps. So that's the current way to do it. You probably like it to be sort of more directly. You don't need to have the Azure subscription as well. But as far as I know, currently you have to, even if you don't use it, and you don't pay any money for it, you still have to have an Azure subscription.
One of our clients already have Office 365.
Yeah.
They want to provide our app.
Yes.
To be able to activate it.
So I think currently the workflows, they do have to add an Azure subscription, even if they don't use it. Because the Azure Active Directory is exposed through the Azure portal. It's not exposed separately as far as I know. I can find out for you. I can search around. I think at one point it was, but I don't know if it's kind of a supported product feature. And early on they kind of had, if you want to try this out, if you don't know, just go to this website and do kind of a sample. But I think that was more of a preview thing rather than a product thing. I think the last time I went to said, do not come here again. So I think the official way into the directory is through the Azure subscription. So you do get single sign-on, you still have to go through the hassle of going to one web page to configure the subscription, even if you don't actually use it. But it is a neat feature. If you've got corporate-facing apps, you should really try and get into this directory. I was visiting a customer a few weeks ago. As soon as they saw it, they said, okay, we're working construction. Who else is in it? The construction tab, and there's like 2 other competitors. So we need to be in this list. So here's on the Bruno's got the thing.
So here's some of the steps that we can take. So notice I'm going to Active Directory in the portal. I'm going to say new. So I'm going to provide some information about my new directory. The directory, what is a collection of users, and there's a product called DirSync, which lets you sync up your cloud-based directory services with on-premises. So in this case, we're adding a directory, the Bruno directory. Notice the domain brunoturkley.onmicrosoft.com is the domain. So I'm going to drill into it by hitting the arrow, and now I'm going to go and add a user. So I'm going to go over here and do just that, add user, click on the bottom. I'm going to call that user Azure user. And notice once again the domain here, brunoturkley.onmicrosoft.com.
So you can provide a vanity domain. I mean, that's the one that comes with it, it's the basic. You can always just put your own domain in there instead. You can switch to that one. So it's not, you don't have to use Microsoft.com.
Now here you need to be careful because I gave that user administrator privileges instead of just being a regular user. That means what? That they can actually manipulate the directory. They can modify the profile in there. So then I go and get a password, not a big deal. And then here I am, I've got that user added. So exercise 2 is now the web app. How can the web app leverage Azure user as we see here? My web app needs to leverage that user. And I'd like to display the name of that user and other attributes that I've entered into the portal. So we go to our app, we say new project. Now here's where it got dramatically easier with 2013. before, people couldn't even do the last lap. Now it's kind of built into 2013. So I choose my ASP.NET web app. I'm going to do an MVC app. But the key thing is I'm going to do change authentication. So rather than a membership provider that typically comes with an ASP.NET web app, I'm going to change authentication, and I'm going to sign in with my credentials. Remember, I'm administrator here. I'm going to, enter in a real password. And I'm going to, as Neil was saying, there's the different types of accounts. So we're going to choose the organizational account. So I'm going to do cloud-based single organization. I'm going to choose the domain like you saw me enter. And this one's a pretty ambitious one. Notice it says read and write. So whoever logs in can do a lot of damage theoretically here.
You can't delete.
Yeah, in fact, at the portal, you bring up an interesting point. Watch this. This will upset people, but I have to be transparent here. So if I go to ACS, Active Directory, I was practicing, and guess what I can't do here at the bottom? What's missing? What can you not do with this list? What would you want to do besides add? Delete. You cannot delete.
So currently you can't delete. Obviously Microsoft didn't ask for deletion, because what happened was when they first did in preview, a number of people accidentally deleted things they shouldn't have deleted, and it's painful. So they turn deletion off until they can come up with a more robust way of handling it. Because people are much more upset at having their directory deleted than they are than not being able to delete the directory. But,
And for me, it's confusing.
Yeah.
Because I'm like, well, which one am I doing again? Is it BT expenses or ABC expenses, or which one is it?
So Bruno's showing you the workflow if you don't already have Office 365. Because if you have Office 365, you already have it directly behind the scenes. You just have to add the Azure subscription in to get access to it.
It's also tracking. I mean, if you have somebody in the directory, they're doing things and then they leave the company,
Yeah.
if you delete them, it's going to delete all of their entries. If you're in an active directory situation, you want to leave them in there and deactivate them,
Yeah,
so that you can go back and do it.
If you're an enterprise, most likely you have an on-prem AD anyway, because you deal with the local stuff, and you do DirSync, and this is really just a replica of the DirSync thing. So you're not really managing it from you. So you can either have local users that are managed like DirSync from on-prem, or you can have cloud users that can manage at this level. So
But you don't really want to delete somebody because
you just want to turn them off.
you lose their history.
Yeah, you just want to turn them off.
Yeah, if you get sued or some kind of funky thing happens, you want to be able to go back.
So it is, even if you do Bruno's workflow with Office 365, you can still do DirSync into this directory. It's still totally valid and did it, and it works. Or you can just do cloud only, like there's no on-prem stuff.
So we're ready now. We pretty much, you don't have to write any code for this demo at all. You're pretty much now ready to run the solution. We're going to basically just continue there, and sure enough, you can see that the user got added, or they got authenticated rather. Now my other blog post shows you what else you can start doing, and this is the one of 2012, and you'll notice that that one is a lot more of a pain in the neck. You've got to go on to this identity and access, and besides, this is 2012. You can't do it 2013. This is not there on 2013. Remember, that was on when we created the web project, you were able to go and click that button. That's the way to do it now, not this way. So you can have both ways. So you go through all this fun configuration, you have to play around with a config file, and here is where you can start writing code to manipulate the social graph. Let me just go find that. So that's signing out.
It's probably a hint that this particular sample wasn't upgraded to 2013. That's probably a good hint, but you probably shouldn't use it. The social graph stuff is still, the graph API has been around for a year, but the tooling is changing. This is an area that's changing very rapidly, industry-wise changing rapidly, and Microsoft's really, the Active Directory team is revving software every 6 weeks right now. So samples get out of date pretty quickly. They're just trying to make the tooling and the usage as easy as possible. So it's important to stay up. I mean, if you're actually working in this kind of keep looking at newer stuff. Samples from last year aren't really that good at this point because the tone's changed and maybe APIs are changing. But the general idea of what you can do, try to simplify authentication, simplify authorization, and simplify access to Graph API. That's the focus. All within the context of Azure Active Directory. That's kind of the way forward.
Here's the 2012 way to get a list of users from the directory. So some simple code. And by the way, to do this, you have to go download, and I'd like to know if this is still relevant, this Graph API helper file. So on the developer network, this is a sample file that has all the code you'd need to kind of go manipulate Active Directory. But notice, it hasn't been updated yet. It's 2012. So this is part of the other lab. If you have 2012 and you want to go play with it, the post is there. But the one I gave you was the one I just showed you, which had no code, no one, just click in the wizard.
Yesterday, the Active Directory team showed us a bunch of samples of different like authentication, authorization, with various modern ways that they released like the last month. It's on GitHub. It's something like AZAD helper or something like that. Maybe you can find it.
I think the next step would be to go watch the build video and see what Vittorio's thinking about the future and go down that path.
Tell us a small difference between different kind of groups you can create between the AD graph and Office 365 using Office 365.
Do you know much about the different types of users we can add to the Active Directory?
Not the groups.
The groups?
The security groups and the mail network groups.
Yeah, I don't know what they are. I saw that yesterday. I don't know what the difference is. I know groups is a thing that AD is changing. They keep improving it because it wasn't there like a month ago or 2 months ago. It's a fairly recent addition. And so it's changing. I was looking. I can ask. I should have asked this. I'll sort of reach out and get. Trying to find the link to the labs.
One of the things you can go do here is look in the PowerShell, and that's like a single location that gives you all the different types of things you can do, like new MSL group. I bet you that has some stuff there about what type of group you can add if I hyperlink into that. Right, so I think the next best step would look at the PowerShell documentation. I think that's the single cleanest place to go get all your.
You're already using it, you have it when it comes to creating groups and adding users. For example, if you have a distribution group, you can try to add users to it. You should use it when I try to use that for Graph API.
I see, okay.
But when I do a security group, I consider using it in both areas, whether it's in Azure or
I can forward emails internally and try to get specific questions answered. Yeah, I can see why this would be a challenge given how fast it's changing. Security is a moving target. So that lab is there for you to enjoy. You know, I'm here we're still here, we'll stick around as long as you guys want to. I'm going to leave it optional if you want to do the labs now or later, but we covered a lot of material. Let's go back to the portal and just kind of dot our eyes a little bit, validate that we covered what we set out to do, which in my view was for you to walk away knowing, roughly speaking, what Azure has to offer. And I think if you can understand the portal, it's a great kind of way to measure your knowledge. You could kind of, tonight at dinner when your family asked what you do today, you said, hey, you should have seen that left cane menu. Let's go through a couple of other ones and give you an elevator pitch on this. So we did storage, we did SQL database and all that, but what about HD Insight? That is big data. So if I go over here, you can go spin up your own Linux VM. In fact, we have that project over here. It's on GitHub. Let's see, Azure, no, I need to go to Documents. So when you want to spin up a big data cluster, you can do it a couple different ways. You can go and provision the VMs yourself, which I think would require a fairly healthy dose of fortitude. Or you can go and edit, like create these programmatically. So if you look at, for example, this one over here, here's some PowerShell script that goes ahead and installs some certificates, get the Azure virtual machine. That's that one. EDH main. This is going in. That's not the one I'm looking for. So these are ways for you to go and spin up. Let me show you this one here. So here's how you create a new VM. And you can do this in a loop. And so if you wanted to provision your own HD Insight, your own Hadoop cluster, you can do a bunch of PowerShell to build a bunch of these Linux VMs and configure them. I actually do a whole hour talk on how to build up your own single node cluster in Hadoop, but you'd probably conclude at the end, that was a lot of work. There must be a way for I can just go to HD Insight now and create a cluster with 32 nodes. And you'd have Hive and Pig. All that tooling would be involved here if you did this. Is this crazy? Does anyone do big data? Here? Big data is like a huge topic now.
Well, depends on who is thinking. Like, if you ask people from Facebook, they think a small data is everything.
Yeah, so how you measure what big data is. Even this decision here, how do I know I need 32 nodes to solve my problem? You necessarily don't. You have to look at the data, what you're trying to ask of the data. And it's probably the hottest field right now. If you go to dice.com and you look up data scientists, it's very much in demand. So HD Insight is what? It's Hadoop. Hadoop as a service, much like the database as a service. Media services, I have a bunch of videos. I want to encode them for iPhone, Android, desktop, TV. I can encode them all with a service. Add watermarks to my videos, manage a workflow, upload, download, do streaming video. That's what media services is about.
Did anyone watch the Olympics, the Canada-US hockey game? That set a world record for live streaming through Windows Azure. It was all hosted in a media services. 2.5 million simultaneous.
Service bus we talked about. Visual Studio Online, Neil discussed it was a way for you to edit a production system through a browser.
So that's the moniker. That's the project moniker. Visual Studio Online is kind of like Team Foundation service, but hosted by Microsoft in the cloud. So it's like an online service. So you can configure you can have your Visual Studio on-prem, like on your laptop. Point to Visual Studio Online in the cloud, do all of your sort of check-ins to the cloud, and then set up configure build servers out there. You kind of get the whole continuous deployment running for a completely cloud-hosted back-end. So you can either configure TFS as the back-end for it, or Git as the back-end. That's what you're running Git these days. I like that workflow. So it's basically an online check-in system built into a configurable build system, a Microsoft build system, so you can then do continuous deployment of it. The thing I talked about earlier was kind of this project, lightweight project version. And this is Visual Studio is a fairly major service from Microsoft.
But there is no big benefit. For example, if I put all the code in GitHub, I already can share it like other people, and that's my online service. What's the big benefit for me then?
Well, there's a lot of enterprises that have a big commitment to like the whole Microsoft tooling set. Team Foundation Service. It's like Team Foundation Service as a service in the cloud. So if you're using GitHub and find it, there's no point in doing it. But a lot of enterprises have got a big commitment already. So the whole Visual Studio TFS workflow, and this is providing them a way to do it in the cloud.
Well, GitHub is more of a repository, whereas TFS is an entire software development lifecycle system.
Well, you can use a couple too. For example, you use Jira for one thing, and then you use GitHub for using both of the systems people know, so instead of using TFS.
So it's one of these, you have choices, there's no good choices.
But I mean, I just trying to say that's the pretty much replication, the same thing, right? Just if you get these people use Jira plus GitHub, I don't need to say that we need.
Yeah. To some extent, it's a competitive reaction from Microsoft because GitHub's doing well, so they're doing this in the cloud. I mean, they're trying to do a lot of stuff in the cloud. It's clearly a competitive reaction to GitHub. But, they're moving. That's another team that's moving pretty fast. So now you can do the whole. It used to be just use check-ins and nothing else. Now it's check-ins and build a deployment out of it. So they're trying to create an enterprise quality back-end development system as a service. It's getting a lot of high pressure attention from good people working in that team. But it's sort of, they're also trying to hook it directly in. So like Windows websites can be hooked directly into. It can also be hooked directly into GitHub. But one benefit is you can hook it into the build system that comes out of Visual Studio Online. And it's a bit tricky to hook it into build system coming out. You can hook it into Jenkins coming out of GitHub, for example. And you can hook it directly into Visual Studio Online.
Well, there's the same thing, right? Because Microsoft suggests like a group of services. For example, it's like Windows Azure, but there's other hosting companies who allow you to use cloud of Windows, and just like it's very tricky to configure everything to work there. It's not that easy when you just use reconfigure for Windows Azure. That's the same thing, right? Yeah. So that's why you're saying that this might be easier at some point. But the problem is that people don't know these services.
Right? Oh, it's only just become available. I think it just GA'd this month.
Yeah, like if you like ask people, 99% will know how to use GitHub and like how many.
But a lot of enterprises don't use GitHub, but they will use this. So it's one of these things. Startups tend to use GitHub, not Visual Studio. That's why you get all the free tools from this part.
There you go. All right, let's move on. Let's wrap up. Again, we'll be around for any specific questions. Caching. Here's the cache. You can go up to 150 gigabyte cache. That's this cache over here. BizTalk, EDI. Businesses in a supply chain, you want to do a translation of data and deliver it. Adapters, anyone in the biz part is a BizTalk enterprise space. It's an enterprise play for companies that need to work together with data flows. Recovery services, backup. Content delivery networks, right? You want to bring your content closer to your users. Scheduler, this to some extent will replace, remember with our worker role that was going in the background and reading the queue? This is perhaps a replacement for that. This is brand new.
I have a question. CDN is updating once a day, or they have like what's the update rate?
I think you configure it. I think you see the things last as long.
Time to live.
So like Amazon had like I think 1 day, and that's what's like tricky for startups when you're changing everything. Right? So you have to use Amazon S3 because it doesn't have that. There you go. So this one doesn't have any.
I don't know the time this is a replacement for a service that was there before that kind of time to live. So I think it's the same. But it's only going to do it for a week.
Networks, pretty important here. This lets us set up a VPN. So if you go to, say, Amazon and you order 5505, so go to the Cisco 5505. This is a VPN device you can go buy for $300-400. So this would go buy this, plug it in your home network, boom, VPN using Azure. Set up a few things. It even gives you the management. Azure will give you, hand you the configuration file for your local machines. So your routers, that is.
But there is an even cheaper way to do it. So there's two different VPNs.
Site to site.
So you create in Azure, you go to this tab, create a VNet. You can create subnets in it, then allocate your cloud service to VNets, etc. Create a VPN gateway, which does cost $5 a month. Then there's two different types of VPNs, site-to-site and point-to-site. So Bruno just explained the site-to-site. Site-to-site is really aimed at sort of IT pro and enterprises, in which you have a hardware device on the client side, although you can use Windows Server as the client, and join the two networks together. The other one is point-to-site, which is really developer-focused, and it's really intended at just a couple of developers kind of want to access the service. So I have a point-to-site in my laptop. A point-to-site one, you create the gateway in the cloud like you do, and then on the client, you create two certificates. You create a master certificate, and then you create a client certificate for every PC that you're going to use to connect to the VPN. And you upload the master certificate to the gateway. And say, here's the master certificate for authentication. And then you use traditional Windows RAS. You just go to networks to connect to this VPN. You download a connection string of some piece of software you download from the system. It's very small. It's more or less just a configuration of your RAS. It's actually happened so fast, half the time I didn't believe it happened. We usually expect some kind of interaction at the point to get. When I've configured it, I call this like a tutorial, like a 3 or 4 page tutorial showing how to create the certificate, etc. And typically, the only thing that is wrong with me is the certificates end up in the wrong store. So if something goes wrong, the likelihood is that it's in the admin store rather than your user store. And other than that, it's been pretty much brain dead easy to set up a point inside VPN. Side to side, as I say, is more like download the script that the IT guys do. But for developers, the point inside can be easy to set up. MSDN account, you can just do it. The nice thing about using the VPN is you don't need to go through the public internet anymore. You just go through the back for services, etc. Right? Yeah. So it's a pretty convenient thing.
So VPN's kind of a very big deal for on-premise hybrid cloud scenarios. Traffic manager, we talked about that. Management services, this is more about getting alerts and so on.
Operation logs is every time you do an operation, a management operation, like create a service, deploy a service, there'll be an entry in the operation log of who did it. So you can look at the history and sort of query the history of who's done changes to your Windows Azure services.
So you can see we built these today and it's in here. Active Directory, we just finished up. Add-ons, remember this is things in the store that some companies might sell. And setting, this has to do with certificates and kind of more or less.
So the management certificates up there is the one I said that you need for like authenticating management operations from PowerShell and CLI. Although PowerShell is starting to move towards using OAuth as well. But for if you're trying to automate it, you might not want to OAuth. So you create a self-signed certificate, upload it to this management certificate area, and then you can use that for authentication. The problem is you've got to be fairly careful of these certificates because with that certificate you completely control the subscription, so you don't want to leak them anywhere. Administrators is a tab. The next one over is you can add additional administrators to your system, like co-admins and stuff. And then affinity groups was historically a thing that you could provide a name to a region in the data center in which you could co-locate your compute and storage services, not any other service, just compute and storage. And the idea is that they'd have a lower latency than if they're just randomly placed in the data center. These data centers are big. The Chicago data center is the size of 7 football fields. They have like 100,000 servers in them. So they've got a bunch of routers and then down a bunch of routers to get over here. About a year and a half ago, Microsoft flattened the network out pretty significantly and made it much more performant. There's less talk now of the lower latency from an affinity group. But if you're going to use a VNet, you have to use an affinity group. So if you're going to create a sort of service correctly, you first of all create an affinity group, create a storage account in the affinity group, create a VNet with the subnets, etc. Then create your services inside the appropriate subnet and deploy inside. That way everything's in the same affinity group and you get the lower latency, etc. And so the other benefit of affinity group, it makes it a bit easier to sort of just remember where you're placing services. Because as I said, I've had people placing services in different data centers because they kind of didn't think they were looking. So I'm going to always use this affinity group for all my services, even though it's all in the same data center. So that's really all there is to affinity group.
All right, so I'm going to just basically Neil and I are going to open the floor up, see if there's any other. I think we went into every single one of these. The course itself doesn't really do that, but I figured it's a good exercise to just kind of know the flow. Are we good?
So one question that it seems to be kind of a fundamental problem that I see is what about DNS? So even if you record, you don't have static IP in websites and web roles.
So with web roles, with the cloud services, IaaS and PaaS, you get a DNS name that you create. That's permanent. Once you create it, that's permanent. You need to use something.cloudapp.net. So you have to use CNAME into that. If you have something deployed, as long as you always have something deployed, you will get an IP address that remains static as long as you have something deployed. If you delete everything, you'll lose the IP address. And there is no way.
The problem with that is naked domains, you can't use a CNAME.
Yeah, so at least some of the providers will let you do kind of a forwarding, like I know GoDaddy does because I've done it. You can forward from the naked to the WW and then see in that.
So you have to have some sort of provider that.
Yeah, that supports that. I know for sure that GoDaddy does, and I think a bunch of others do at this point.
Network Solutions does.
So you can basically, I'm not sure the exact term, but something like forwarding the naked domain to the actual one. And then see in that. So this is one of the issues that at this point in time, Microsoft does not provide standard IP. You can't buy something else.
Yeah, that's one, because our whole DNS is in Amazon. Now, it's hoping to move everything, but unfortunately, we have to move it somewhere in Solutions or GoDaddy or. Okay. I guess we could just pass and order it from what that is.
The other trick people have done is just leave like an extra small part. Sometimes put it in Ireland, you do that. Azure is different. The PaaS will survive. If you do like a VIP swap instead of saying there, you do savings, production, vice versa. That does not affect the IP addresses. Also, if you do an in-place upgrade, if you remember this morning we had a sort of mentioned upgrades and the concept of upgrade domain. And that comes from the upgrade domain concept comes from IaaS services. That's what the original. With an upgrade domain, if you deploy 5 instances of web role, you can actually 5 upgrade domains, 0 through 4. Typically, by default, it's 5 upgrade domains, and so I just go through them. So then, if you do an application upgrade, or Microsoft does a host or guest OS upgrade, you'll take the application upgrade domain 0 down, and leave the 1 4 running. So bring it back up, then bring upgrade domain 1 down, and keep going. So an upgrade domain service remains pretty much run. It'll be a little bit degraded, like 20% degraded or less than that, depending on the upgrade domain you have. But it will still remain there. You won't lose the IP. In a VIP swap, you won't lose the IP. The only way you'll lose the IP is if you actually delete the deployment. Which does happen. You have to lose it like that. In an IaaS, you know, there's some part of the service is doing an extra small run if you're really concerned with it. Just to keep the IP in there. With IaaS, there's other IP address, the internal one, the VIP, the dynamic IP address. Until about a month ago, these were allocated using special form of DHCP. So Microsoft would give you an IP, administratively as a different IP address.